The camera is pointed downward, but there is nothing to see, only black water. Not the familiar kind of darkness that waits in a room after a lamp is switched off, or the blue shadow under a passing cloud, or the gentle dimness of a winter morning before the sun has made up its mind. This is older darkness, heavier darkness. It presses against the glass of the submersible as if it has weight, as if the ocean has been slowly gathering all the forgotten nights of the world and storing them here, below the reach of weather, below the turning moods of the sky. The pilot says nothing for a while. In front of him, a small constellation of instruments glows green and amber. Depth, heading, battery, oxygen. Outside, the searchlights reach forward and vanish, swallowed after a few meters by drifting particles and the endless liquid distance. Every now and then, something crosses the beam, a pale thread, a tumbling speck, a transparent animal so delicate it looks less like a living thing than a thought that has not yet decided on a body. Then the lights are turned off. For 1 second, the world disappears. The cabin is still there, the metal frame, the breath in the microphone, the quiet scrape of a glove against a control stick. But outside the viewport, the ocean becomes absolute. No horizon, no floor. No up, no down. Just a depth so complete that the human mind begins searching for edges and finds none. And then, out in the black, a light appears. It is not white, not exactly, not the white of a bulb or a camera flash. It is bluish, soft, almost hesitant. It blooms once, then fades. A few seconds later, another light answers from somewhere lower. Then 2 more, faint and distant, like sparks rising from a fire no one can see. They do not illuminate the water. They do not reveal the landscape. They simply exist for a breath and vanish, leaving the darkness strangely more alive than it was before. Down here, light is not background. It is not taken for granted. It is a decision, a warning, a trap, a name called into emptiness. Somewhere above, far beyond the pressure and the cold, the sun is still burning over the ocean surface. Waves are lifting and falling. Clouds are moving. A gull may be holding itself in the wind over a fishing boat. The day may be bright enough to make people shield their eyes, but none of that reaches this place. The sunlight that touches the sea begins losing itself almost immediately. Red is taken first, then orange, then yellow. The warm colors vanish in the upper water, absorbed molecule by molecule, until the world becomes blue, and then dimmer blue, and then something like memory, and finally, nothing at all. The strange thing is that the ocean does not become empty when the sun disappears. It becomes secret. The last light beneath the ocean is not the last trace of the sun. It is what the living world makes after the sun has been removed. To understand that light, we have to descend slowly, not only through water, but through expectation. Because the ocean teaches in a way land does not. Land displays itself. Mountains stand in daylight. Forests have edges. Rivers move where we can see them. Even deserts, for all their silence, are visible to the eye. But the sea hides most of itself beneath a surface so reflective that it gives the sky back to us and keeps its own interior concealed. For thousands of years we lived beside it, crossed it, feared it, prayed to it, harvested from it, and still knew almost nothing of what was below the first brightness. A sailor leaning over the side of a ship at noon sees only color and motion, a sheet of blue or green, a sparkle of broken sun. The imagination may fill the depth with monsters or gods, with drowned cities, with silence, with treasure, with punishment. But the actual ocean remains underneath, layered, moving, populated, immense. It is not a single place. It is a vertical world, changing with each meter, each degree, each slight failure of light. At the surface, everything seems obvious. Wind touches water and makes texture. Sunlight scatters. Foam writes itself in temporary lines. Small fish flash silver in the shallows. Phytoplankton turn light into food with a quiet industry that helps breathe the planet. Coral reefs, when the water is clear, can appear almost impossibly crowded, built from color and appetite and rivalry. Here, in the upper realm, sight still belongs to the sun. Shadows have direction. Hunters can use speed. Prey can vanish among brightness. The day matters. This upper layer is often called the sunlight zone. It is the thin, illuminated skin of the ocean, the part most familiar to us, the part where photosynthesis can occur, and where much of the visible abundance gathers. Yet it is only the beginning, a narrow brightness stretched over a planet-sized depth. Beneath it, the light weakens. The water grows colder. The easy world of surfaces gives way to a slower geography. At about 200 meters, depending on the clarity of the water, the sea has already changed its character. The sun is not gone, but it is no longer sovereign. It arrives as a diluted rumor, a blue haze with no warmth in it. If you were suspended there at noon, the surface might still exist as a faint ceiling overhead, but the distance below would open into dark water, and every direction would feel less certain. This is the beginning of the twilight zone, the mesopelagic, a realm that is neither day nor night, but something between them. It is here that the ocean begins to feel like a question. The animals of this middle depth live under a vanishing sky. Many have enormous eyes, shaped not for the luxury of vision, but for the emergency of it. Some look upward, searching for silhouettes of prey or predator against the last blue light. Some carry mirrors in their skin. Some are transparent. Some are blacker than the darkness around them. Some make light from their own bodies, precise and brief, like coded messages written in chemistry. The twilight zone is not quiet in the way we imagine. It is filled with movement, but much of it is vertical. Every evening, as daylight fades above, countless animals rise toward the surface to feed. Fish, squid, crustaceans, gelatinous creatures, small drifters, and quick hunters begin a nightly ascent that can span hundreds of meters. Before dawn, they sink again, returning to dimmer water where visual predators have a harder time finding them. This daily migration is so vast that sonar operators once mistook it for the seafloor itself, a false bottom that lifted and fell like a breathing continent. There is something haunting about that image, an entire living layer moving under the ships of the world, invisible in daylight, rising at night, falling before morning. The sea, breathing in darkness. And beneath that migrating layer, beneath the last daily negotiations with sunlight, the world becomes stranger still. By around 1,000 meters, even the faintest trace of the sun has been extinguished. There is no dusk here because there was never evening, no dawn because morning never arrives. The water is cold, the pressure immense, and the only lights belong to animals, machines, or rare geological fires on the seafloor. This is the midnight zone, and its name is almost too human. Midnight suggests a clock, a turn toward morning, a darkness with an ending. But in the deep ocean, the night does not pass. it continues. For creatures living here, darkness is not a condition, it is the medium. A fish does not enter this blackness the way a person enters a cave. It is born into it. Its body is shaped by it. Its hunger, its fear, its mating, its camouflage, its patience, all of it is written in relation to light that is scarce enough to become powerful. A single flash can reveal, a single glow can mislead. A row of tiny lamps along the belly can erase a silhouette. A lure can turn curiosity into death. A burst of brightness can startle a predator long enough for escape. We tend to think of light as the opposite of darkness. Down here, light belongs to darkness. It is one of darkness's languages. The chemistry is simple to describe and difficult to feel. A molecule reacts. Energy is released. Photons are emitted. In many animals, oxygen meets a light-producing compound in a controlled reaction, sometimes with the help of an enzyme, sometimes inside specialized organs, sometimes through symbiotic bacteria housed like lanterns within living tissue. But to reduce bioluminescence to chemistry alone is to miss the intimacy of it. A creature in the deep does not glow for spectacle. It glows because somewhere in the black water, another body is watching, or hunting, or waiting to be found. Imagine a small fish drifting in the midwater, its underside dotted with photophores, little organs that release blue-green light. Above it, the last faint glow of the surface, almost gone. Below it, a predator looking up. Without light, the fish would appear as a dark shape against the dim water overhead. But by producing just enough glow from its belly to match the weakening light above, it dissolves its own outline. It becomes less visible by shining. This is counter-illumination, a lantern used as camouflage. A body pretending not to be a body. Elsewhere, a jellyfish pulses once when touched, sending a blue ring outward through its bell. The flash may startle whatever brushed against it, or it may summon something larger, a burglar alarm in the deep, attracting the enemy of its enemy. A squid releases a cloud not of ink, but of light, a glowing decoy that hangs in the water while the animal slips away. A dragonfish carries a lure beneath its chin and, more remarkably, can emit red light invisible to many of its neighbors, a private beam in a world tuned mostly to blue. The darkness has rules. Life keeps finding exceptions. For a long time, the deep ocean was imagined as a desert, too cold, too dark, too pressured, too far from plants, too far from warmth, too far from the sunlit engine of life. Even after early sounding lines began to measure depth, even after nets brought up strange bodies from below, there was still a belief that the deeper sea must eventually become lifeless. It seemed reasonable. All food, we thought, came ultimately from sunlight. If light could not descend, perhaps life could not either. But the ocean did not ask permission to be reasonable. It hid abundance under pressure. It built ecosystems around falling crumbs. It carried energy downward in the bodies of the dead, in sinking plankton, in fecal pellets, in transparent houses abandoned by larvaceans, in the slow snowfall of organic matter that drifts through the water column. Marine snow is a gentle name for something profound. It is the rain of the upper world, the remains of sunlight made edible, sinking through darkness, grain by grain. A particle may take weeks to fall. It may be eaten and released and eaten again. It may become part of a shrimp, then a fish, then a squid. It may finally touch the abyssal floor as a pale fleck in a place that has never seen noon. Every depth has an economy. Every darkness has a way of receiving what falls. The deeper we go, the less the ocean resembles the one we carry in our minds. There are no waves in the ordinary sense, no sunlight pattern rippling over sand, no bright coral gardens. The water column opens as a vast volume, not a landscape. Animals are often widely spaced, conserving energy in a world where meals can be rare. Some drift with mouths open, some wait in postures of extreme patience. Some have stomachs that stretch around prey nearly as large as themselves, because in the deep, one opportunity may need to last. Here, beauty becomes difficult to separate from survival. A siphonophore may trail through the dark like a living thread of glass, many bodies joined into one colonial organism, each part specialized, the whole creature extended across meters of water with lethal grace. A comb jelly refracts the lights of a submersible into bands of color, not because it is glowing that way, but because rows of beating cilia scatter the artificial beam. A gulper eel opens a mouth so large it seems like a mistake drawn by evolution in a moment of extravagance. A Dumbo octopus moves by flapping ear-like fins, soft and almost gentle, over a plane where pressure would crush an unprotected human body in an instant. The deep is not another planet. It is this one, refusing to be simple. And at the center of this refusal is light. Not light as certainty, light as negotiation, light as debt, light as hunger, light as the faintest proof that even where the sun cannot enter, the world has not surrendered to blindness. On a clear day, seen from orbit, the ocean looks almost polished, a blue veil around the planet, broad, calm, impossible to hold in one thought. The continents interrupt it, but they do not dominate it. The sea wraps around them, fills the spaces between them, rises and falls against their edges, stores heat, carries storms, remembers ice, receives rivers, and covers mountains taller than any range on land. From above, it looks like color. From a beach, it looks like distance. From a boat, it becomes motion. But to descend into it is to realize that the ocean is not a surface at all. It is a volume, a deep, layered, breathing architecture of water. The first meters are bright enough to seem familiar. Sunlight arrives in shattered pieces, sliding over ripples, bending, scattering, making ladders that sway over sand or vanish into open blue. A diver near the surface can still feel connected to the air. The body knows where it belongs. Bubbles climb upward. The lungs measure time. The skin feels warmth. Colors remain close to themselves. Red on a wetsuit is still red. Yellow fins are yellow. A face behind a mask is recognizable. But water is not air with more resistance. Water edits light. It absorbs and scatters it with a quiet selectiveness. The warm end of the spectrum begins to disappear quickly. Red fades first, not dramatically, but with the steady erasure of a word left in the rain. Blood becomes dark. Orange becomes dull. Yellow weakens. Blue remains longest, which is why the clear ocean carries that haunting color. Not because blue is painted onto it, but because blue survives the journey better than the others. The deeper the descent, the more the world is simplified by what the water removes. At 30 meters, the sun is still strong, but color has already become uncertain. At 50, the surface is bright yet distant. At 100, daylight feels less like weather and more like a memory overhead. At 200, in many places, the ocean has entered twilight. The boundary is not a line. It changes with season, with latitude, with plankton, with sediment, with storms that stir the upper water into cloudiness. In clear tropical seas, light may travel farther. In green coastal water full of life and particles, it can fade much sooner. But somewhere below the upper layer, the sun loses its practical authority. Photosynthesis becomes difficult, then impossible. The plants of the sea, the microscopic drifters that gather light and make sugar, no longer have enough illumination to build a living from it. And yet animals continue. They gather at the border where light is weak enough for hiding, but strong enough for seeing. This middle realm, the ocean twilight zone, is one of the great half-known regions of Earth. It is not remote in the horizontal sense. It lies beneath every ocean basin, beneath shipping lanes, storms, islands, military routes, fishing grounds, and calm blue days. It begins close enough that a falling anchor chain might point toward it, but it remains largely unvisited because distance downward is different from distance across. 200 meters is not far on a map. It is far for a body that breathes air. It is far for sunlight. It is far for certainty. A small animal living there has to manage a series of impossible compromises. Rise too high during the day, and it may be seen. Stay too deep at night, and it may miss the feast. Glow too brightly, and it may call death toward itself. Glow too little, and it may fail to find a mate, or fail to disappear against the dimness above. The twilight zone is a place of thresholds. Bodies there are often built like solutions to narrow problems. Lanternfish, among the most abundant vertebrates on Earth, carry patterns of light organs along their sides and bellies. These patterns are not decoration. They may help species recognize one another in the dark. They may break up the outline of a body. They may act as signals in a vast water column where scent disperses, sound travels strangely, and sight is both dangerous and necessary. Many twilight animals are made of compromise itself. Their eyes may point upward, enlarged to capture scraps of light falling from the surface. Their backs may be dark, their bellies faintly luminous. Some are red or black because red light is nearly absent at depth, turning red skin into a kind of invisibility. Some are silvered like knives, reflecting the dim environment around them. Some are almost entirely transparent, their bodies withholding themselves from view. The ocean makes secrecy anatomical. For a human observer, the twilight zone feels empty at first because we are used to landscapes. We expect forms: a wall, a tree, a road, a hill. In the midwater, there are no such anchors. There is only suspension. The water above, the water below, the water everywhere. A camera lowered into it may film drifting particles for a long time before anything large appears. A submersible may move through what seems like nothing, and then suddenly pass a creature so strange and fragile that it seems impossible the same planet made it. This is one of the difficulties of understanding the deep sea. It does not always reveal itself in scenes. It reveals itself in encounters. A squid appearing in the beam and gone. A salp chain turning slowly through black water. A transparent head with green lenses inside it. A fish with teeth like needles and a body no larger than a hand. A jelly with a stomach visible through its bell. A flash that might have been an animal, or the warning from one, or the bait from another. The ocean does not show everything at once. It gives fragments, and asks us not to confuse fragment with absence. There are times when technology hears what the eye cannot see. During the Second World War, sonar operators began noticing a strange reflecting layer beneath their ships. It looked like a bottom, but it was not where the bottom should be. Stranger still, it moved. It rose at night and sank in daylight. The false bottom was alive, made from countless organisms suspended in the water column, many of them with gas-filled swim bladders or bodies that reflected sound. It was a migrating community so large it could deceive machines designed to read the shape of the sea. At dusk, the layer loosens. Animals begin to rise. The movement is not theatrical. It does not happen as one perfect curtain lifting. It happens in countless individual decisions shaped by hunger and fear. Copepods, krill, small fish, squid, gelatinous animals, predators following prey, prey avoiding predators. Upward, where the surface waters hold more food. Downward again before the light returns. The daily vertical migration is sometimes described as the largest migration on Earth, not because one herd crosses a plain, but because the water column itself comes alive in motion. Every night, in oceans around the world, the deep rises to feed on the remains of day. There is a kind of beauty in that dependence. Sunlight builds food near the surface. Phytoplankton drift and divide. Tiny grazers eat them. Larger animals eat those grazers. At night, animals from below climb into this illuminated inheritance. By morning, some carry carbon back down in their bodies. Some excrete it at depth. Some die and sink. In this way, the migration becomes part of the planet's carbon cycle, a biological pump moving material from air-touched water into the deep. Darkness is not separate from the sunlit world. It is connected by appetite. But the relationship is not sentimental. The ascent is dangerous. The surface at night is not safe. It is only safer than the surface by day. Moonlight can be enough to change behavior. A bright moon can keep some animals deeper. Clouds may encourage them upward. Predators know the rhythm. The migration is a negotiation with illumination, so subtle that changes in the sky can echo hundreds of meters below. Think of that for a moment. A cloud passing across the moon. A change in light too faint for a person on a ship to notice, and far below, animals adjusting their position in the black. The ocean feels indifferent until we begin to understand how exquisitely sensitive it is. The last light beneath the ocean is not only the last photon from the sun, it is also the final authority of light over behavior. Long after the surface has disappeared from view, the memory of daylight continues to organize bodies in the water. It tells them when to rise, when to hide, when to feed, when to become invisible. In the twilight zone, the sun is weak, but it is still law. Below, the law changes. The descent past 1,000 meters is not a passage into empty space. It is a passage into a civilization of darkness. The temperature settles near cold. The pressure increases with every 10 meters, adding the weight of another atmosphere, until the idea of an unprotected human body becomes almost absurd. Airspaces collapse. Materials behave differently. Machines must be built like answers to violence. And yet many animals there are not armored in the way we might expect. They are soft, gelatinous, efficient, composed less like fortresses than like agreements with pressure. Pressure is not a crushing event for them. It is home. Their cells function within it. Their membranes, enzymes, and structures are adapted to it. A creature from the deep brought too quickly to the surface may be destroyed not by the deep, but by leaving it. The world that would kill us is the world that holds it together. This reversal matters. It reminds us that the ocean is not hostile in itself. It is hostile to us. The deep does not know it is extreme. It is simply itself, continuing in conditions that human language frames as limits: darkness, cold, pressure, scarcity. To the animals here, those are not obstacles to life. They are the grammar of life. And light, because it is rare, becomes intensely meaningful. A brief flash can travel through dark water farther than a color could near the surface. Blue-green wavelengths move well through the sea, so many marine lights are tuned toward them. A glow may be hidden from certain eyes and obvious to others. Some animals use filters and lenses. Some arrange photophores in rows. Some can dim themselves. Some release luminous mucus. Some produce sparks when disturbed, turning touch into visible alarm. The deep sea is not a void filled with occasional lights. It is a place where light has been refined into behavior. If a city uses light extravagantly, the deep uses it economically. Nothing is wasted. The glow of a living body down there is not for us. That is perhaps the most difficult thing to remember. We arrive with cameras and name the beauty after wonder. We call it a light show, a spectacle, a hidden galaxy. But for the animals, it is risk and necessity. A blue flash may mean, "Do not eat me." A green lure may mean, "Come closer." A pulse may mean, "I am here." A line of organs may mean, "I am not here at all." A body may shine to survive, or survive by refusing to shine. The ocean did not invent light for human awe. It invented light because in darkness, a signal can become a body reaching beyond itself. There is a particular cruelty in trying to film natural darkness. The camera wants light. The human eye wants light. The story we bring with us wants a subject separated from the background, an outline, a face, a beginning and an end. But the deep sea gives us animals that have spent millions of years avoiding exactly that. They are built against detection. Their lives unfold in a theater where the audience is dangerous. So the first thing our machines do is change the scene. A remotely operated vehicle drops through the water with lamps bright enough to startle animals that have never known daylight. A submersible carries a small artificial noon into the midnight zone, and wherever that light falls, the hidden architecture of bodies appears. A fish turns. A shrimp flees backward in a snap. A jellyfish drifts through the beam like a torn umbrella made of glass. Beyond the lamps, there is only blackness, but we have to remember that the blackness is not empty. It is merely unlit by us. This is why some of the most revealing deep-sea observations happen when scientists try to disturb the darkness as little as possible. Low-light cameras, red lights, lures that imitate bioluminescent signals, instruments left quietly in the water. The more gently we look, the more the deep begins to behave like itself. One famous approach used a lure meant to resemble the distress display of a jellyfish. In the deep, a glowing alarm can attract larger predators, and by imitating such a signal, researchers were able to call rare animals toward the camera. The idea was simple, almost childlike. If the darkness speaks in light, answer in light. But the implications were vast. We were no longer only shining lamps into a hidden world. We were trying, however imperfectly, to listen in its own language. That language is not universal. It is full of dialects. The blue spark of one animal may be invisible to another. The steady glow of a belly may be tuned to match the dim light overhead. A flash may be timed to the movement of a fin. A lure may sway with the patience of a hanging fruit. Some lights are bacterial, maintained through partnerships between animal and microbe. Some are produced internally. Some are expelled into the water. Some are shielded, focused, filtered, shuttered. There are organs in the sea that function like lamps, mirrors, lenses, curtains, and dimmers, all grown from flesh. The lanternfish is small enough to fit easily in a human hand, but its importance is difficult to exaggerate. It lives in numbers so large that the imagination fails. It rises and falls with the daily migration. It carries light organs in patterns that can help identify species. It feeds, is fed upon, moves carbon, links the surface to the deep, and spends its life in the half-lit border, where visibility is a danger and invisibility is never complete. In a documentary, it might appear for only a few seconds, silver and trembling under a net light. In the ocean, it is part of a planetary mechanism. There are anglerfish too, though the familiar image can make them seem like caricatures of deep-sea horror. Teeth, darkness, a glowing lure. But the reality is more intimate and stranger. Many female anglerfish carry a bioluminescent lure, often inhabited by bacteria that produce light. In the black, the lure becomes a false promise. Something small approaches, guided by hunger or curiosity, and finds a mouth instead. In some species, males are tiny compared with females and live their lives searching through an immense dark for a mate so rare that finding her becomes the central problem of existence. The deep does not waste romance on abundance. There are fish with tubular eyes, like the barrel eye, whose transparent head contains green lenses that can rotate to look upward for silhouettes and forward when it feeds. There are bristlemouths with delicate bodies and fearsome jaws, among the most numerous vertebrates on Earth, though nearly invisible to human culture. There are hatchetfish, flattened and silver, their bodies shaped like blades, and their undersides lined with light. There are dragonfish with dark bodies, long teeth, and a capacity for producing red light that many deep-sea creatures cannot see, allowing them to illuminate prey without announcing themselves in the common language of blue. That detail feels almost fictional. A predator carrying a private color, a hidden lamp in the dark. But deep-sea life often feels fictional because we are late to it. The animals did not evolve to fit our categories of believable. They evolved in water, under pressure, in darkness, across time spans that make human strangeness look brief. They are not monsters. They are consequences. Even gelatinous animals, sometimes dismissed as simple, become extraordinary in this realm. Jellies, siphonophores, ctenophores, salps, larvaceans. Many are so fragile that nets destroy them, which means they remained poorly known until cameras could observe them in place. A siphonophore can be a colony of specialized individuals functioning as one organism, an arrangement that unsettles our idea of where a self begins and ends. Some cast nets made of tentacles through the water. Some drift like luminous handwriting. Some are long enough to make a whale seem compact. And because their bodies are mostly water, they are almost perfect citizens of the water column. They do not fight the sea with bone and muscle in the way a land animal might. They inhabit it with transparency, buoyancy, softness. In the lights of a vehicle, they can look like decorations from a dream. In reality, they are hunters, filters, traps, and meals. The deep sea has a way of making softness dangerous. It also has a way of making slowness powerful. On land, speed often dominates our imagination. The chase, the leap, the strike. But in the deep ocean, energy is precious. Food may arrive unpredictably. A large meal can be separated from the next by long stretches of emptiness. Many animals conserve movement. They hover, drift, wait. Their metabolisms may be low. Their bodies may be watery and delicate, reducing the need for heavy tissue. A predator may not patrol like a wolf, but suspend itself like a question, mouth ready, lure moving slightly, waiting for the rare mistake of another life. To understand this world, we have to abandon the assumption that drama must be fast. Down here, an ambush can take hours. A fall can take months. A signal can last less than a second and matter more than a day. The last light beneath the ocean often appears in brief events, but those events belong to long patience. In the water column, the boundaries between animal, weather, and darkness blur. A storm far above can mix the surface and alter the rain of particles. A bloom of plankton can feed a chain of grazers, then predators, then sinking remains. A dead whale can fall from the sunlit world and become an entire chapter on the seafloor. A carcass descending through the water is not only an ending, it is a delivery. Whale fall. The phrase sounds ceremonial, and in a way it is. When a whale dies and sinks, its body carries enormous energy into the deep. Scavengers may arrive quickly: hagfish, sleeper sharks, amphipods, crabs, worms. Soft tissues are stripped. Bones remain, rich with oils that can support specialized communities for years. Microbes break down lipids, producing sulfide that chemosynthetic bacteria can use, creating conditions with echoes of hydrothermal vent life. A whale that spent its life surfacing to breathe can become, in death, an island of food in the dark. There is tenderness and brutality in that image. A body made from krill and travel and breath, falling through kilometers of water. A feast appearing where scarcity is ordinary. The deep receives the dead without ceremony, yet life gathers there with precision. Nothing is merely wasted. A fish falls. A jelly falls. Wood washes from land and sinks. Seaweed torn from kelp forests drifts down. Even dust from continents, carried by wind and rivers, finds its way into the ocean's chemistry. The abyss is fed by the surface, but not generously. It survives on fragments. This changes the meaning of darkness. Darkness is not absence. Darkness is where patience has become ecological. The abyssal plain begins around 4,000 meters in many descriptions, though like all ocean boundaries, it is not a wall. It is one of the largest environments on Earth. Broad, cold, dark, under pressure, covered in fine sediment that settles slowly from above. If a camera moves over it, the scene may appear minimal. Mud, tracks, a sea cucumber, a brittle star, a sponge standing like a glass sculpture, the occasional fish, pale and unhurried. But the plain is alive with small processes. Microbes work in sediment. Animals sift, crawl, burrow, feed. The seafloor holds records of what has fallen through time. In places, the mud is interrupted by stones that took millions of years to grow. Polymetallic nodules, dark lumps containing metals gathered slowly from seawater and sediment. They sit in quiet fields across parts of the deep ocean floor, and because human industry has begun to notice them, the abyss has entered a new kind of light: the attention of extraction. Machines may someday cross areas that have been undisturbed longer than human civilization has existed. A nodule the size of a potato may be older than cities, older than agriculture, older than our stories of the sea. The last light beneath the ocean is therefore not only natural, it is also technological. Headlamps, survey beams, mining lights, research lamps, the glow of screens on ships above. The deep, once hidden by darkness, is being made visible in pieces, and visibility has consequences. To see a place is not always to protect it. Sometimes it is to desire it. Sometimes it is to measure it for removal. Sometimes it is the first step in learning how fragile it is. This is the uneasy edge of deep-sea exploration. Wonder and appetite travel together. The same tools that show us a ghostly octopus, a field of glass sponges, or the blue pulse of a jelly can also map mineral deposits, survey future mining zones, trace routes for cables, and reveal resources. Human attention is never neutral for long. The ocean has hidden itself well, but not completely. And yet, without looking, we cannot know what is there. Without knowing, we cannot care for it intelligently. So the camera descends. The lights come on. A world appears, startled and ancient, in the narrow cone of our arrival. For most of human history, the seafloor was less a place than an idea. It existed beneath sailors as danger, and beneath philosophers as mystery. Lead lines could touch it near coasts. Nets could scrape parts of it. Broken cables proved its roughness. Soundings gradually replaced imagination with numbers, but numbers are not presence. To know that a basin is 5,000 meters deep is not the same as seeing a pale animal cross the sediment, or watching a plume of black mineral smoke rise from a chimney in a place no sunlight has ever reached. When scientists first hydrothermal vents in the late 1970s, the discovery altered more than oceanography. It altered a quiet assumption about life itself. The scene was deep, near the Galapagos Rift, in darkness and cold. Researchers expected geology, warm water, chemical traces, perhaps mineral formations where seawater entered cracks in the crust, heated near magma, and returned to the seafloor altered and enriched. The vents themselves had been predicted. The chemistry made sense. But around those openings, in the absence of sunlight, there were communities of animals so dense and strange that they seemed to have been waiting for human certainty to fail. Giant clams, mussels, shrimp, white crabs, and tube worms rising from the seafloor in clusters, their red plumes exposed to the water, their bodies rooted in tubes, some reaching extraordinary lengths. No green plants, no algae harvesting light, no familiar foundation of a food web. Instead, bacteria and archaea were using chemical energy. They were taking compounds from vent fluids, such as hydrogen sulfide, and building organic matter through chemosynthesis. Life did not require sunlight directly. It required energy. Sunlight was one source, vast and obvious, but here was another, rising from the interior of the Earth, carried in superheated water, released through cracks in the planet's skin. The discovery did not mean the sun was irrelevant. The oxygen in the surrounding seawater, necessary for many vent processes, came from a planet shaped by photosynthesis. The ocean is interconnected in ways that resist simple separations. But still, vents proved something emotionally enormous. The dark seafloor was not only receiving life from above, in some places, it was generating abundance from below. The last light beneath the ocean, at a vent, is not light in the ordinary sense. It is chemical opportunity. It is energy without dawn. Approach a black smoker with the lamps of a submersible, and the scene can look almost mythic. A chimney rises from the seafloor, built by minerals that precipitate as hot vent fluid meets near-freezing seawater. The fluid may be hundreds of degrees Celsius, kept from boiling by the crushing pressure. It pours upward, dark, with fine sulfide particles, like smoke from a fire that cannot burn. Around it, animals cluster in a world of extremes. Scalding near the flow, freezing just beyond it, toxic to many forms of life, rich for those adapted to its chemistry. The vent field is not peaceful, but it is alive with a different tempo. Fluids pulse, chimneys grow and collapse, Microbes form mats. Crabs pick through surfaces. Shrimp crowd near warm chemical flows. Tube worms host internal bacteria that make food for them, allowing the animals to live without mouths or digestive systems in the usual sense. Their bodies are partnerships, built around invisible labor. What looks like an individual is, in a deeper way, a community. This is one of the ocean's recurring lessons. A life is rarely only itself. The glow of an anglerfish lure may come from bacteria. The survival of a vent worm may depend on bacteria. Coral reefs depend on symbiosis. Human bodies depend on microbial worlds. The deep sea, which once seemed to represent isolation, keeps revealing connection. Vents also remind us that the seafloor is not a static floor. It is part of a moving planet. Plates separate and collide. Crust is made and consumed. Water enters rock, changes, rises. Minerals fall out. Landscapes are built in darkness. A vent field may flourish for decades and then fade when the plumbing below shifts. A chimney that seemed permanent can stop flowing. A community can collapse. Elsewhere, a new crack opens. Warm fluid escapes, microbes bloom, and animals begin to gather. Even in the abyss, there are beginnings and endings. There are neighborhoods of heat. There are ghost towns. There are colonies founded by larvae drifting through black water, carried by currents between islands of chemistry. The animals at hydrothermal vents are often described as alien, and the word is understandable, but it can be misleading. They are not alien. They are intensely earthly. They belong to tectonics, chemistry, seawater, microbes, pressure, and time. They show us not an escape from Earth, but a deeper version of Earth than the one we normally inhabit. They make the planet feel less familiar because they reveal how narrow our familiarity has been. In recent years, exploration has complicated the story further. Scientists have found that vent life may not be confined only to what we see on the seafloor surface. Beneath thin plates of lava, within cavities in the ocean crust near vents, animals such as tube worms, snails, and worms can inhabit warm, fluid-filled spaces. The vent ecosystem, already strange, extends into the rock itself. The boundary between seafloor and underworld becomes less clean. Life is not only around the opening, it is in the hidden passages below. There is something quietly astonishing about animals living beneath the seafloor in darkness under darkness. A secret under a secret. It suggests that every time we define the limit of life, life may already be working just beyond it, not in defiance, but in continuity. We draw borders because our instruments stop there. The planet does not always honor them. Hydrothermal vents have also become part of a larger imagination about life beyond Earth. If organisms can thrive in darkness around chemical energy on our own seafloor, then icy moons with subsurface oceans become more interesting. Europa, Enceladus, worlds far from the warmth of the sun, with oceans hidden beneath ice, perhaps with rock-water chemistry below. The deep sea becomes not only a habitat, but an analogy, a laboratory for thinking about life where sunlight is weak or absent. The last light beneath our ocean may help us imagine life where no sky is visible at all. But there is a danger in turning vents too quickly into symbols. They are not only clues to aliens, they are living places now. They are inhabited by animals with their own histories, their own reproductive cycles, their own vulnerabilities. Vent communities can be resilient in some ways because they live in dynamic environments, but they are not invincible. Disturbance can matter. Mining interest in seafloor massive sulfides, the mineral deposits associated with hydrothermal systems, raises questions that are not abstract. What does it mean to remove structures that took time to form and support specialized life? How much do we understand before we act? How do we weigh minerals against ecosystems that were unknown within living memory? The deep sea often enters human attention as either miracle or resource. It is both more ordinary and more difficult than either category. A vent crab is not a miracle to itself. A sulfide chimney is not a resource to the worm attached to it. The categories belong to us. The place belongs to a broader reality, one we are still learning to describe. Beyond hydrothermal vents are cold seeps, where methane, sulfide, or other chemicals emerge from the seafloor at lower temperatures. They too can host communities based on chemosynthesis: mussels, clams, tube worms, microbial mats. Some seeps are associated with continental margins, with sediments, with the slow escape of hydrocarbons. They do not always have the dramatic black plumes of vents, but they carry the same quiet lesson. The dark ocean floor is not merely a receiving surface for crumbs from above. In some places, the earth itself feeds life from below. This reverses the old picture. The deep is not a basement. It is a set of worlds. Some are fed by snow from the sunlit surface, some by corpses, some by wood, some by whale bones, some by methane, some by hot mineral water, some by slow microbial work in sediment. Energy arrives in many forms, and life, patient and inventive, gathers wherever the flow is enough. If you could move across the deep seafloor without disturbing it, you might travel for long stretches over quiet sediment where animals are scattered, and the pace seems almost lunar. Then, without warning, a vent field would appear in the lights. Chimneys, shimmering water, white animals, black fluid, surfaces stained with minerals, the sense of a furnace hidden beneath ice-cold water. The contrast would feel impossible. Desert, then city, night, then chemical dawn. But it would not be dawn for long. Vents are temporary. The seafloor opens, the vent breathes. Minerals gather, animals arrive. The chemistry changes, the flow slows, the community shifts. Eventually, the chimney may go dark, and the animals that depended on it must disperse, die, or wait for another opening somewhere in the abyss. Even the most extraordinary light in the deep is not guaranteed. That may be what makes it feel so alive. It appears where conditions meet. It lasts while they hold. Then it returns to darkness, leaving behind minerals, shells, tubes, traces, and the possibility that somewhere else, out beyond the reach of our maps, another black smoker is beginning to breathe. There is a point in the descent where the ocean stops feeling deep in any ordinary sense. The word deep works well for a swimming pool, a lake, a harbor channel, even for the blue drop beyond a reef where the bottom falls away and a diver looks down into a darker shade of water. But in the open ocean, depth becomes more than a measure. It becomes an environment that changes. Matter, movement, sound, temperature, and imagination. Then, below the abyssal plains, the seafloor breaks again. Trenches open where tectonic plates bend, and one slab of earth begins its long descent beneath another. These are not simply holes. They are narrow, immense wounds in the planet's crust, and they hold the deepest waters on Earth. The Hadal Zone begins around 6,000 meters and extends downward into the trenches, in places approaching 11,000 meters below the surface. The name comes from Hades, the underworld, but even myth has trouble keeping up with the physics. At those depths, pressure is not a dramatic moment. It is a constant reality, a force so large that it changes what machines can be and what bodies must become. A human standing unprotected there is not a human for long. A submersible must be engineered as a small, deliberate contradiction, an air-filled object surviving where air-filled objects should not survive. The Mariana Trench is the most famous of these deep places, and within it, Challenger Deep has become a kind of emblem for the downward limit of the ocean. Its measured depth varies slightly depending on method and location, but modern surveys place it around 10,900 meters, deeper than Mount Everest is tall above sea level. That comparison is often used because the human mind needs to turn vertical distance into a shape it recognizes. Put the mountain upside down into the trench, and still the water would cover it. But even that image fails because a mountain has air around it. The trench has weight. To descend there is to pass through nearly the entire vertical story of the ocean. Surface brightness, twilight, midnight, abyss, then the trench. The walls slope downward, sediments gather. Organic matter can funnel into these narrow depressions, making them in some ways more food-rich than nearby abyssal plains. The trench is not simply a dead endpoint. It is a trap for particles, a corridor of geology, a habitat with its own pressures and patterns. Amphipods live there, sea cucumbers, microbes, specialized fish in some trenches, though even fish have depth limits. The animals are not monstrous in the way old maps might have imagined. Often they are pale, soft, and adapted with quiet precision. Hadal life is a reminder that extremity is relative. We speak of crushing pressure because we imagine our own bodies there, but the animals of the trench are not being crushed. They are held in a world where pressure is normal. Proteins must function. Cell membranes must remain useful. Buoyancy must be managed. Food must be found. Reproduction must occur. The solutions are biochemical, anatomical, behavioral, and still incompletely known. The trench is not an empty pit. It is a living question under enormous weight. The light there is almost entirely foreign to the place. No sunlight, no blue remnant, no twilight law. If light appears, it is made by animals, by microbes, by the instruments of visitors, or by the rare disturbances of geology and chemistry. A baited camera on the seafloor becomes a temporary moon. Amphipods gather in the beam. Sediment rises. A pale fish may enter, slow and strange, its body shaped not for our aesthetic of strength, but for the invisible pressures of its home. When the camera is gone, the trench returns to the darkness that is not emptiness, but the ordinary condition of all its hours. It is tempting to imagine the deepest place as the final secret. Once we touch it, once a probe lands or a submersible reaches the bottom, the mystery should be solved. But the ocean does not work that way. Arrival is not understanding. A footprint in sediment, a sample, a video, a temperature reading, a pressure record, a few hours of observation inside a trench thousands of kilometers long. These are beginnings, not endings. The deepest ocean is not one place. It is a patchwork of trenches separated across the planet, each shaped by geology, currents, food supply, and history. A person can reach the bottom of Challenger Deep and still barely meet it. That is one of the humbling truths of deep exploration. The heroic moment is real. The engineering is real. The courage is real. But the ocean remains larger than the event. A descent captures a line through the water, not the volume. A camera sees what passes before it, not what avoids the light. A sample contains the organisms that survived collection, not all the lives that could not be brought upward intact. Every expedition expands knowledge and exposes the size of what is still unknown. In the Hadal Zone, even sound feels transformed by scale. The water is not silent. It carries distant earthquakes, shifting sediments, biological noises, the low travels of whales far above, the mechanical signatures of human presence. Sound moves through water efficiently, bending with temperature, pressure, and salinity. In a trench, the shape of the seafloor may channel or reflect it. The darkness may be absolute to sight, but the ocean is not mute. It has always been filled with signals beyond human hearing, a vast acoustic interior long before we put hydrophones in it. Still, light remains the symbol we return to, because it is how we imagine revelation. To see is to know, we think. To illuminate is to solve. But in the Hadal Zone, the act of lighting can feel almost intrusive, like opening a door into a room whose inhabitants have never consented to day. The animals do not need our lamps. Some may avoid them. Some may be drawn to them. Some may be unaffected. But the beam is always an event, a foreign weather. This makes footage from the deepest ocean feel both precious and incomplete. The view is narrow, often ghostly, a pool of light on sediment, particles moving past, a small animal crossing. The rest is black. Yet that blackness is the majority of the image. It is also the majority of the truth. We are not seeing darkness as a failure of the camera. We are seeing the habitat. The deepest animals live in a world where the sun is not even a memory, not in behavior, not in color, not in rhythm, at least not directly. And yet the surface still reaches them through food. Organic particles sink, carcasses fall, sediments slide, pollutants too arrive. Plastics, persistent chemicals, traces of human industry have been found in deep places once imagined to be sealed away from us. The trench is remote, but not separate. There is no separate ocean. The water connects, gravity connects, chemistry connects. What happens above can descend. This is perhaps the most unsettling form of light we bring into the deep. Not a beam, but consequence. A candy wrapper in a trench, a fiber in an animal, a chemical signature in tissue. The deepest darkness on Earth is not beyond our reach, after all. That fact can feel like accusation, but it can also become a form of responsibility. The Hadal Zone does not need to be romanticized to deserve care. It does not need bright colors, charismatic mammals, or familiar landscapes. It matters because it is part of the living planet, because it contains histories older than our institutions, because its organisms are solutions to conditions we are only beginning to understand, because ignorance is a poor excuse for damage. When we picture the last light beneath the ocean, we may imagine the final spark of an animal in black water. But in the trenches, another possibility appears. The last light may be the small lamp of a lander resting on sediment at the limit of the sea, surrounded by pressure, watched by creatures adapted to a darkness we can barely endure for an hour. The camera records. The bait sways. The animals approach. Above them, 11 kilometers of water stand between that little pool of brightness and the sky. And then the batteries weaken. The mission ends. The lander releases weight and rises. The light lifts away from the sea floor, growing dimmer to anything below until it is gone. The trench remains. Not conquered, not solved, only briefly visited. Down there, darkness is not waiting to be filled. It has its own fullness. It has weight, chemistry, hunger, movement, and time. The last light is not the end of the place. It is only the end of our seeing. Before cameras descended, before submersibles carried people behind thick windows, before remotely operated vehicles hovered over vent fields and trenches, the deep ocean entered human knowledge through fragments. A rope lowered until it stopped. A weight touched mud. A net returned torn or heavy or glittering with animals no one had expected. A cable snapped in a storm and had to be recovered from depths that made engineers reconsider the shape of the sea floor. The earliest sciences of the deep were sciences of interruption. Something came up from below, and the surface had to decide what it meant. Sailors had long understood the ocean as dangerous, but not necessarily as deep in the modern sense. The sea was a road, a grave, a weather system, a provider, a border. The bottom mattered near land, where ships could run aground, anchors could hold, and fishermen knew where to lower their lines. Far offshore, depth became abstraction. There was water below, perhaps immeasurable. What lived there belonged to rumor. Then sounding became systematic. The sea floor gained numbers. The numbers became charts. Charts became routes, cables, strategy, geology. But even as the bottom emerged into measurement, the water column between surface and floor remained strangely invisible. A ship could pass over thousands of meters of living water and experience it only as distance. Instruments could tell pressure and temperature, but not the feeling of a siphonophore drifting through a black current, not the moment a lanternfish dims itself under moonlight, not the slow descent of marine snow past the last visible blue. The Challenger expedition in the 19th century marked one of the great beginnings of ocean science. It crossed the world, gathering depth soundings, temperatures, sediments, and biological specimens. It brought up life from places some had assumed lifeless. It helped dismantle the idea of an azoic deep, a depth without animals. But specimens hauled to the surface are changed by the journey. Soft bodies collapse, colors shift, pressures release, behavior disappears. A creature in a jar can prove existence, but it cannot show a life. For that, the eye had to go down. The first deep-sea photographs and later films were revelations, but also distortions. A flash in the dark freezes an animal into our own visual expectations. A trawl net turns a three-dimensional drifting existence into damage. A lighted camera records what the light attracts or frightens. Every tool asks the deep a particular question, and the answers depend on how the question is asked. This is true of all science, but in the ocean it becomes physically obvious. A net cannot catch a delicate jelly intact. A bright lamp cannot observe natural darkness unchanged. A baited lander cannot show ordinary behavior without bait. A submersible cannot be invisible. Yet each tool reveals something. The trick is humility, to remember that method is not the world. When humans entered the deep in person, the experience changed language. A scientist could now say not only what the instrument measured, but what it felt like to watch black water close around the viewport. Accounts from submersible dives often carry a mixture of technical precision and awe. The descent is slow. The surface fades. The temperature outside drops. The sphere creaks or settles. Instruments tick through depth. Then, beyond the last daylight, flashes appear in the darkness. First rare, then more frequent, as if the ocean were full of tiny nervous systems responding to the vehicle's passage. Imagine being inside that small chamber, a few people in a metal or acrylic enclosure, a cable of communication to the ship above, or no cable at all. The knowledge that outside is an environment your body cannot enter. The lamps reveal a circle and nothing more. A fish appears and disappears. A shrimp reflects the beam with jeweled eyes. A jelly passes, carrying its own faint blue weather. This is exploration at the edge of human scale. Not because the distance traveled is the greatest, but because the body is so obviously out of place. Space travel has rockets and fire and public spectacle. Deep sea travel often begins with a quiet lowering over the side of a ship, a vehicle becoming smaller beneath the waves until it is gone. The drama is vertical and silent. The danger is pressure. The destination is not above the world, but inside it. The submersible Alvin, launched in the 1960s, became one of the icons of this work. It helped scientists visit the sea floor, study vents, observe animals, recover objects, and bring human presence into places once limited to instruments. Other vehicles followed. ROVs extended reach and duration. Autonomous underwater vehicles mapped large areas with patient precision. Landers carried cameras and bait to depths beyond human-occupied routines. Fiber optic cables allowed pilots on ships to move robotic arms kilometers below, manipulating tools in black water by watching screens lit in control rooms. There is something almost dreamlike about that arrangement. A person in a warm room on a ship, hands on controls, a robot hand moving in darkness at the bottom of the sea, a crab stepping away from the claw, a sample box closing, a light turning sediment gold for the first time in perhaps thousands of years. Modern ocean exploration is full of such split realities. Above, the ship rolls under weather, coffee cools beside monitors, people speak in low voices so they do not miss a detail. Data streams in, navigation numbers update. A video feed shows a world that looks impossibly calm compared with the waves overhead. The seafloor does not know about the storm. The storm does not know about the sea cucumber crossing the screen. The human side of deep exploration is often quieter than we imagine. It is not always the triumphant shout of discovery. Much of it is waiting, descending, checking systems, watching particles, logging coordinates, cleaning sensors, troubleshooting a thruster, losing sight in sediment stirred by a landing, repositioning, waiting again. Then suddenly, something appears. An animal no one expected, a rock formation that changes a map, a shimmer in the water that hints at venting, a field of sponges, a flash of blue from a disturbed creature. The long patience makes the moment sharper. Discovery in the deep often arrives without fanfare. It crosses a monitor while someone is leaning forward, trying to decide whether the shape in the distance is biology or stone. Because the ocean is so large, even repeat visits can feel like first visits. A canyon wall may host coral gardens that have never been seen. A seamount may rise into currents and gather life like a submerged island. A trench slope may hold tracks from animals not yet identified. The water column above any of these places may contain fragile species that never touch the bottom and rarely survive capture. The deep is not a museum of fixed exhibits. It is a set of processes happening in darkness, and we are lucky when our instruments intersect them. This changes the meaning of the phrase unexplored. It does not always mean no one has been there. It can mean no one has been there at the right season, with the right camera, at the right hour, using a light dim enough not to change the behavior, or a sensor sensitive enough to notice the chemistry. It can mean the place has been mapped, but not watched, sampled, but not understood, crossed by a cable, but never truly seen. The ocean resists completion. Even the surface, the part we think we know, is restless. Beneath it, layers move, mix, separate, rise, sink, breathe. Water masses formed in polar regions can travel through the deep for centuries. Currents carry heat, salt, oxygen, larvae, plastic, memory. A drop of water in the abyss may not have touched the atmosphere for a very long time. It may move in darkness through basins and around ridges, part of a circulation so vast that human lifetimes seem like brief surface weather. To explore the deep is therefore not merely to visit depth, it is to enter time differently. The animal in the beam may live slowly. The coral may be centuries old. The sediment may accumulate millimeter by millimeter. The nodule may grow across millions of years. The water itself may carry a history of distant cooling, sinking, and travel. Against that timescale, the submersible light is almost nothing. A blink, a match struck in a cathedral and then blown out. Yet that blink matters because it gives us a glimpse. It allows a name, a question, a protection, a correction to an old assumption. It reminds us that darkness is not a reason to simplify the world. The last light beneath the ocean may be the glow of an animal, but it may also be the glow of human curiosity made visible by technology. A lamp lowered into a place where lamps do not belong. A screen lit in a control room at 3 in the morning. A scientist's face illuminated by footage of an animal no human eye has seen before. These are also part of the story now. The danger is thinking that our light is the center of it. It is not. Our light arrives late, it leaves quickly. The deep continues in its own darkness, full of signals too faint, too brief, too specific for us to notice, unless we learn how to look with patience. A living light is not fire. That may seem obvious, but it matters. Fire is heat made visible, a violent oxidation, a hunger that consumes what feeds it. Bioluminescence is different. It is cold light, or nearly cold, made through biochemical reactions so efficient that very little energy escapes as heat. In the deep sea, where energy is precious and warmth is scarce, this matters. To glow without burning, to signal without wasting, to make photons as carefully as a body makes enzymes, membranes, eggs, and muscle. There are many versions of the chemistry, but the basic idea is a reaction that releases energy in the form of light. A light-producing molecule, often called a luciferin, reacts with oxygen, sometimes helped by an enzyme known as luciferase, or by related proteins and cofactors. Different organisms have different systems. Some make the components themselves, some obtain them through diet. Some rely on symbiotic bacteria that live inside specialized organs, glowing in exchange for shelter and nutrients. The word bioluminescence sounds singular, but the ocean has invented it again and again. This repetition is important. When evolution arrives at a solution many times, the problem must be deep. In the sea, the problem is visibility. Near the surface, vision is shaped by sunlight. In the open deep, vision is shaped by the possibility of light. Many animals have eyes even where sunlight cannot reach, because darkness is not the same as blindness. Bioluminescent flashes create scenes, brief but useful. They allow animals to detect one another, lure prey, confuse attackers, identify mates, hide silhouettes, and perhaps communicate in ways we barely understand. If no light existed down there at all, eyes would be less useful. But because animals make light, other animals evolve to see it. And because they can see it, light becomes more powerful. The deep sea is an arms race made of darkness. A predator evolves sensitivity to faint blue flashes. Prey evolves blacker skin to absorb light instead of reflecting it. A hunter evolves allure. Another animal evolves suspicion. A fish hides its outline with belly lights. A predator learns to look for mismatches. A squid releases glowing fluid. A larger predator follows the glow. No single trick remains absolute. Every adaptation enters a world of other adaptations. The result is not balance in the peaceful sense, but a restless, intricate tension. Bodies become arguments. Lights become counter-arguments. Darkness becomes the paper on which both are written. Some of the most fascinating deep-sea animals are not bright to our eyes when undisturbed. Their light is controlled. A photophore may have reflectors behind it, lenses over it, pigments around it, shutters to cover it. The body can aim or dim the signal. Imagine growing a lantern not as an object held in the hand, but as part of the skin, wired to nerves, supplied by chemistry, tuned to the color of seawater, used in decisions that can determine life or death. This is not decoration. It is sensory strategy. The color of deep-sea light is usually blue or blue-green because these wavelengths travel farthest through seawater. Red light disappears early in the descent, which creates both limitation and opportunity. Many deep animals cannot see red well because red is not normally available. Some predators exploit this with red bioluminescence or red filtered light, illuminating prey while remaining hidden from animals tuned to blue. It is as if a hunter in a dark forest carried a lamp whose color only it could understand. Other animals use light defensively. When disturbed, some jellies produce waves of brightness that move across their bodies. Some brittle stars and worms glow when touched. Some shrimp vomit or secrete luminous clouds, leaving a shining confusion behind while they escape. The light does not always say, "Come here." Sometimes it says, "Look there" instead. Sometimes it says, "I am dangerous." Sometimes it says, "Something has attacked me. Perhaps something larger should come and investigate." A burglar alarm in the midnight zone may not protect the owner by hiding it, but by making the attacker conspicuous. This is a brutal elegance. If a small animal is grabbed by a predator, it may have little chance in a direct contest. But if it flashes brightly, it might attract a bigger predator that threatens the attacker. The first predator releases its prey to avoid becoming prey. The signal turns the food chain against itself. A flash becomes leverage. Not all deep-sea light is brief. Some glows are steady. The counter-illumination along the bellies of fish and squid requires careful matching of intensity. Too dim, and the animal remains a silhouette. Too bright, and it becomes a beacon. The best camouflage is not absence of light, but accurate light. The animal must measure the faint radiance from above and adjust its own glow to blend into it. In this sense, it is not hiding in darkness, it is performing the sky. A creature beneath it looks upward and sees almost nothing. That almost nothing is survival. There are lights for mating too, though we understand them less completely. In the open ocean, finding another member of the same species can be a monumental problem. The water column is vast, bodies are scattered, currents move them, darkness limits vision, chemical signals disperse, sound may travel, but not all animals can use it effectively. A pattern of photophores, a rhythm of flashing, a particular arrangement of glow might help guide the right bodies together. In a world where mistakes waste energy and time, recognition matters. This gives some deep-sea lights a quiet, emotional gravity, at least to human imagination. A signal in black water, produced by a small animal in an enormous volume, may be a search. Not a metaphorical search, a biological one. Somewhere beyond the range of our instruments, two lives may depend on whether a faint pattern is seen and answered. The ocean is full of loneliness. We should be careful not to humanize too much. But it is also full of distance, and distance makes signaling profound. Some animals borrow light rather than making it alone. The Hawaiian bobtail squid, though not a deep-sea animal in the same sense, offers a beautiful example of partnership with luminous bacteria. The squid houses the bacteria in a light organ and uses their glow to reduce its shadow while hunting at night, matching moonlight from above. In the deep sea, bacterial symbioses also appear in light organs of certain fish and squids. The animal provides a home. The bacteria provide illumination. The boundary between self and tool becomes biological. There is a philosophical unease in this. When a fish glows because bacteria inside it glow, whose light is it? The fish uses it. The bacteria produce it. Evolution shaped the relationship. Survival belongs to both. The last light beneath the ocean often comes not from a single organism, but from collaboration so intimate that it looks like one body. Human beings like clear ownership. The sea is less interested. The more scientists study bioluminescence, the more common it appears in the ocean. In the open water, especially in the deep, a large proportion of visible animals can produce light. The exact numbers depend on habitat, depth, methods, and what counts as a visible animal, but the pattern is clear. In the deep water column, living light is not rare. It is one of the major facts of existence. This turns our ordinary idea of darkness inside out. We imagine deep darkness as blank, but a creature living there may experience it as a field of potential signals, a flash behind, a glow below, a faint pulse ahead, a disturbance that sets off sparks in microscopic organisms, a lure swaying, a belly matched to the dim overhead. The darkness is not filled with constant brightness. That would defeat the purpose. It is filled with possibility. The next light may be food, danger, mate, deception, or escape. For us, light often means safety, a porch lamp, a lighthouse, a street at night. In the deep, light is morally neutral. It may guide. It may betray. It may conceal. It may kill. A small crustacean drawn toward a glow does not know whether it approaches a signal or a mouth. A predator seeing a flash does not know whether it has found prey or been summoned into the attention of something larger. A mate-seeking animal must risk visibility to be found. Every light carries a cost. This makes the beauty of deep bioluminescence different from the beauty of stars. Stars are far away, indifferent to our bodies. Deep-sea lights are close, functional, involved. They belong to hunger and fear. When we watch them, we are seeing the visible edge of decisions made by animals in darkness. The glow is lovely, but it is not innocent. Perhaps that is why it holds attention so strongly. It is beauty with consequences. A blue flash in black water is not decoration in the universe. It is a life doing something urgent. The human mind has a habit of turning darkness into absence. We do it instinctively. A dark window at night becomes empty unless a face appears. A cave without a lamp becomes a void. The unlit corner of a room becomes less a place than a possibility. Vision is our dominant sense, and when vision fails, imagination rushes in to finish the picture. That is why the deep ocean has so often been filled, in story, with exaggeration. Monsters, ruins, leviathans, lost worlds. The mind would rather invent a shape than accept a darkness it cannot resolve. But the ocean's darkness is not psychological. It is physical. Sunlight enters water and is changed. The sea is not malicious when it absorbs red, then orange, then yellow, then green, then almost everything. It is not hiding itself with intention. Its molecules interact with photons. Particles scatter light. Life in the upper water consumes and clouds and shades. The result, across depth, is a slow removal of the visible world. Darkness is not an event in the ocean. It is an accumulation. A person descending through clear water may not notice the change at first. The surface remains bright above. The body is occupied with breath and pressure and motion. Then, gradually, the colors alter. The reef loses warmth. A red object darkens toward brown and black. Skin tones flatten. The familiar world becomes blue. Below, the water thickens visually until it seems less like space and more like substance. At depth, without artificial light, even a hand held before the face can disappear. That disappearance can feel like fear. It can also feel like truth. We are not built to be central there. The ocean does not arrange itself around human perception. Most of it exists beyond unaided sight, beyond ordinary breath, beyond casual measurement. To enter it is to be reminded that our senses evolved for a narrow band of conditions: air, daylight, gravity, surfaces, distances that a walking animal can manage. The deep sea is not only dark, it is a critique of our confidence. There is humility in a viewport. A person inside a submersible may see farther than the human eye ever could alone, and yet the field of view remains tiny. The lamps turn the ocean into a moving room. Everything beyond the beam is ungrasped. The pilot may know the coordinates, the depth, the heading, the sea floor map, the mission plan. Still, outside the light, anything could be there. Not monsters in the childish sense, more unsettling, ordinary lives continuing unseen. We often say that exploration reveals the unknown, but it also reveals the persistence of the unknown around every revelation. A lamp does not abolish darkness, it creates a border. In the deep ocean, that border is always visible. The beam ends. The black begins. This creates a strange emotional rhythm in deep-sea footage. The audience sees only what the vehicle sees: a patch of sediment, a rock wall, a pale fish, a coral branch. Then, black water. The mind leans into the screen, trying to extend vision beyond the light, but the darkness refuses. It is not like a forest where a shadow might hide a trunk you can imagine. It is not like a room where a lamp could be moved. It is volume. It has no background. The blackness is not behind the subject, it surrounds it. A fish entering that beam seems to arrive from nowhere. When it leaves, it does not go somewhere we can picture. It returns to unpictured existence. This is why deep-sea animals can feel ghostly even when they are physically present. Their bodies appear without context. They are not framed by landscape unless they live near the sea floor. In the midwater, a creature has no stage except the black. It may drift through our light for 3 seconds, carrying a body plan millions of years in the making, then disappear into a dark that might be a few meters away or infinite. The human response is wonder, but wonder is not enough. Wonder can flatten difference if it treats every strange animal as merely strange. The deep ocean deserves more careful attention than astonishment. A transparent fish is not amazing only because we can see through it. It is transparent because transparency solves a problem in open water. A black fish is not dramatic because it resembles a nightmare. Its darkness reduces reflection. A mouth full of long teeth is not horror design. It is a tool for holding prey when meals are rare. A gelatinous body is not weakness. It is efficiency in water. To see deep life clearly, we have to move beyond surprise. We have to let each form become specific. A viperfish hanging in the dark is not a symbol of menace. It is a predator in a low-food world, equipped with photophores, teeth, and a hinged skull that allows it to take prey efficiently. A vampire squid is not a vampire, and not a squid in the everyday sense, but a deep-living cephalopod with a cloak-like webbing, light organs, and the ability to turn itself inside out defensively. A sea cucumber on the abyssal floor is not simple because it moves slowly. It is part of sediment processing, recycling fallen material in a system where every particle matters. The deep asks us to exchange myth for attention. That exchange is not a loss. It makes the world richer. A monster can be frightening once. An animal can remain astonishing forever. The darkness also changes time. Without sunlight, days do not pass visually. There is no sunrise crossing the sea floor, no sunset reddening a horizon, no moon shadow moving across sand. Some rhythms still arrive from above: tides, seasonal changes in food fall, migrations linked to day and night in upper layers, pulses of productivity after blooms. But in the midnight and abyssal zones, time is not painted by light. It is carried by currents, chemistry, hunger, reproduction, decay, and disturbance. A storm at the surface may send more organic matter downward days or weeks later. A phytoplankton bloom may become a pulse of food in the deep. A whale fall may create a local era. A vent may open and found a community. A landslide may bury one. A nodule may grow so slowly that human history is a brief film passing above it. Without daylight, time becomes less visible, but not less real. This matters because modern human time is fast. Markets move quickly. Technologies update. Ships cross basins. Decisions about deep-sea mining, fishing, carbon storage, cable routes, and conservation can happen in years or decades. But the deep sea contains processes measured in centuries and millennia. A coral broken by a trawl may have been alive before the industrial world. A sponge community may recover slowly, if at all. A sediment disturbance may linger in environments where natural rates of deposition are extremely low. A mistake in the deep can have a long afterlife. Darkness can hide damage as easily as it hides beauty. This is one reason the last light beneath the ocean carries moral weight. Illumination is not merely discovery, it is accountability. Once a place is seen, the excuse of invisibility weakens. Once a species is filmed, it becomes harder to pretend the habitat is empty. Once a migration is measured, the water column becomes more than blue space on a map. But visibility can also invite exploitation, and so the act of seeing must be joined to restraint. The ocean has always been used. Food, travel, war, trade, waste, cables, oil, minerals. The deep was spared not by our wisdom, but by difficulty. Pressure protected it. Darkness protected it. Distance protected it. Now machines are eroding those protections. The question is not whether humans will reach the deep. We already have. The question is what kind of presence we will become there. A respectful presence begins by admitting scale. Most of the living space on Earth is ocean water, and most of that is dark. The illuminated world we know is a narrow surface phenomenon. The planet's largest habitats are not forests or grasslands or deserts, but water columns and deep basins beyond the sun. This should alter our sense of home. Earth is not primarily a land planet with oceans around the edges. It is an ocean planet with land exposed. And most of its ocean is night. This does not make the planet bleak. It makes it stranger, more layered, more alive in ways that do not require our comfort. When a bioluminescent animal flashes in the deep, it is not lighting a void. It is revealing, for an instant, that the void was never void. The flash does not create the world, it betrays it. A blue pulse, a startled ring, a lure swaying, a row of belly lights dimming as the animal turns. Each light is small, but it interrupts a human mistake older than science, the belief that unseen means absent. Down there, in the miles of water below the last blue, unseen things are not waiting to become meaningful. They are already living. The surface of the ocean is often treated as the beginning of a story, but for many deep-sea animals, it is more like weather from another world. They do not touch it, they do not breathe its air, they do not see its daylight in any direct way. Yet the surface governs their lives through falling food, changing oxygen, seasonal pulses, temperature patterns, and the daily movement of animals between layers. The surface is far away and intimate at the same time. A bloom of plankton under spring sunlight can become, weeks later, a faint meal in darkness. A storm can rearrange the upper water and alter what sinks. A change in climate can shift currents, oxygen levels, and the timing of productivity, echoing downward into places where no sunlight ever arrives. The ocean is vertical, but it is not divided cleanly. The zones help us think. Sunlight zone, twilight zone, midnight zone, abyssal zone, hadal zone. The names create a staircase for the mind. They are useful, and they are beautiful in their way. But in the water itself, boundaries are gradients. A photon does not stop at a sign. An animal does not always remain in one layer. A particle does not respect a diagram. Currents move across and through. Oxygen minimum zones expand and contract. Warm eddies intrude. Cold water sinks. Life follows opportunity. Still, the idea of layers helps us feel the descent. The upper 200 meters contain the most familiar blue. It is the ocean of dolphins breaking the surface, of tuna hunting, of turtles crossing light, of reefs, kelp forests, fishing nets, swimmers, waves. It is also the ocean of microscopic labor. Phytoplankton, too small to command our attention individually, collectively transform sunlight and nutrients into living matter. They release oxygen, draw carbon dioxide into the sea, and feed the first links of food webs that reach far below their own tiny lives. In a way, every deep-sea light begins here. Not directly, not always, not simply. Vents and seeps complicate the picture. Chemosynthesis offers another path. But across much of the ocean, the energy that allows a lanternfish to rise at night, a squid to hunt, a jelly to grow, and a particle of marine snow to fall, begins with sunlight captured by microscopic cells near the surface. A photon leaves the sun, travels through space, strikes the sea, enters a living cell, becomes chemistry, becomes body, becomes prey, becomes waste, becomes snow, becomes darkness, becomes another life. Light changes form as it descends through the food web. It stops being visible long before it stops mattering. That is one of the quiet mysteries of the ocean. The sun can be absent as light and present as nourishment. A deep animal may never see daylight, but its body may be made from daylight, transformed through countless exchanges. This gives the phrase "last light" a double meaning. There is the last visible light, fading in the water column, And there is the last biological light, the last usable trace of solar energy moving through bodies, sinking, being consumed, respired, recycled. The ocean is full of such transformations. A copepod grazing near the surface eats phytoplankton. A small fish eats the copepod. The fish descends by day and rises by night. A squid catches it. A larger fish catches the squid. Fecal pellets sink faster than loose particles, carrying carbon downward. Microbes colonize them. Other animals feed on them. What began as a bloom under sunlight becomes scattered through dark water in fragments of tissue and waste, each piece part of a slow rain. Marine snow is not dramatic on film unless one has learned to see it. It drifts through the beam as flecks, threads, soft particles, the constant snowfall of a living planet. To an impatient eye, it may look like visual noise. To the deep, it is supply. It is the surface remembering the depths. It is the upper ocean paying a portion of its abundance downward. Not enough to make the abyss rich everywhere, but enough to sustain communities adapted to scarcity. There is a melancholy beauty in marine snow because it is made of endings. Dead plankton, mucus, shells, fecal matter, fragments of bodies. But in the deep sea, endings are not only endings, they are meals, habitats, chemical opportunities. A particle falls and is intercepted. A larger fragment lands and is investigated. A carcass becomes an event. A whale becomes an ecosystem. Even the smallest descent matters because the deep is a world built around receiving. The surface, meanwhile, is restless and loud. Waves break, light scatters, rain strikes, ships pass, plastic fragments drift, oil slicks spread and thin. Rivers deliver nutrients and pollutants. Satellites measure color from above, using subtle differences in ocean hue to infer blooms of phytoplankton. From space, we can see traces of the microscopic life that feeds the dark, but we cannot see the animals waiting below for the consequences. This separation between visibility and importance is one of the great lessons of the sea. What we can see easily is not always what matters most. The clear blue water of a tropical ocean may look pure and empty, but it may be nutrient poor. A green, cloudy coastal sea may look less beautiful to tourists and yet be highly productive. A dark midwater layer may be invisible from above and still contain vast biomass. The deepest floor may appear barren and still hold intricate microbial and animal communities. Beauty in the ocean is not a reliable measure of abundance, nor is brightness. The eye is easily misled by surfaces. Below the surface, oxygen becomes a critical part of the story. Many animals need it, but oxygen is not distributed evenly. It enters the ocean from the atmosphere and from photosynthesis near the surface. It is consumed by respiration as organic matter breaks down. In some regions, midwater oxygen minimum zones form where decomposition uses oxygen faster than circulation can replace it. Animals living near or within these zones must adapt, avoid, migrate, or endure. A change in oxygen can redraw habitats as surely as a change in light. The deep sea is often imagined as stable, and in some respects it is. Temperatures can be steady. Darkness is constant. Seasonal swings are muted compared with the surface, but stability is not sameness. Currents shift, food pulses, oxygen changes. Geological events occur, human influence spreads. Climate change warms the ocean, alters stratification, and can affect the delivery of oxygen and nutrients. The deep may respond slowly, but slow response is not the same as no response. A warming surface can strengthen layering, making it harder for nutrients from below to reach sunlit water in some regions. Less nutrient supply can mean less productivity, which can mean less food sinking to depth. Changing winds and currents can shift where life flourishes. Expanding low oxygen zones can compress habitats. The effects are complex, uneven, and still being studied. But the central point is simple. The dark ocean is connected to the changing surface. There is no untouched below, only less visible consequence. Even sound from the surface travels down. Ship noise, seismic surveys, military sonar, the low mechanical hum of an industrial ocean. Whales use sound across great distances, and the deep soundscape is part of marine life in ways we are still learning to understand. Light pollution reaches only so far down directly, but noise can travel. Chemical pollution can sink. Plastics can fragment and descend. Fishing gear can break loose and drift or settle. Carbon dioxide absorbed by the ocean changes chemistry, contributing to acidification that can affect organisms with shells and skeletons. The ocean takes in what the surface gives it. For a long time, humans mistook that vastness for forgiveness. The sea could dilute anything, hide anything, carry anything away. But away is not a place. It is only a direction from us. In the ocean, away may mean into an animal, into sediment, into a current, into the deep. The darkness beneath the waves has been asked to receive more than we understood, and still, life continues there. Not because it is invulnerable, because life is persistent in the space between harm and possibility. A deep-sea coral grows in cold water, slowly building structure that other animals use for shelter. A sponge filters particles from the current. A brittle star coils its arms. A fish waits. A microbial community works in sediment. A lanternfish adjusts its glow and rises with dusk. A jellyfish responds to touch with a ring of blue. These are not grand gestures. They are continuities. The last light beneath the ocean is held in such continuities. It is not always spectacular. Sometimes it is a faint organ on the underside of a fish. Sometimes a chemical reaction in a bacterium. Sometimes a camera light sliding over a coral that has grown longer than a human nation has existed. Sometimes the invisible legacy of sunlight in a particle being eaten at 2,000 meters. Sometimes the weak glow of a control screen on a ship while people try, carefully, to understand what their instruments have seen. If the ocean teaches anything through its layers, it is that the world does not become less alive when it becomes less visible. It becomes less available to us. That difference is everything. On the deck of a research vessel at night, the ocean can look almost simple again. Black surface, white wake, a few instruments secured under tarps. The ship's lights making small, trembling paths on the water. People move carefully because wet metal is unforgiving. Somewhere inside, screens glow in the lab. Someone labels sample jars. Someone checks the weather. Someone else watches a cable pay out over the stern, disappearing into the dark with a vehicle attached to it, expensive and fragile and built for pressure. The sea around the ship is not silent. It slaps the hull, hisses along the sides, lifts and drops the vessel with a patience that can become nausea. But the work has its own rhythm. Bolts, winches, radios, checklists, hands on railings, a voice calling depth. There is a humility in watching a machine descend at night. The vehicle has lights, cameras, thrusters, sensors, arms. It is one of the most sophisticated ways humans have invented to look downward, and the ocean receives it without emphasis. The cable enters the water. The vehicle sinks. The surface closes over it. For the people above, the descent becomes numbers and video. 10 meters, 50, 100. The light is still greenish. Particles streak past. A fish startles from the beam. 200 meters. The surface brightness weakens. 400. More flashes appear in the surrounding dark, tiny lights responding to disturbance or moving on their own business. 600. A squid holds at the edge of visibility, then folds backward and disappears. 800. The water outside the beam becomes complete. Inside the control room, no one wants to miss anything. That is the strange tenderness of deep exploration. A room full of adults staring at darkness with the concentration of children waiting for a door to open. When an animal appears, voices change. The pilot slows. A scientist leans forward. Someone asks for a zoom. Someone else checks whether the recording is running. The animal may be common to the deep and rare to human eyes. It may be undescribed. It may be known from damaged specimens but never filmed alive. It may do nothing dramatic at all. It may simply drift, turn, pulse, and move out of frame. But in that moment, a life that has always existed beyond ordinary seeing becomes part of human knowledge. The encounter may last less than a minute. The analysis may take years. What species was it? What depth? What temperature? What was it doing? Was the behavior natural or a response to the vehicle? Was it feeding, avoiding, signaling? Was that glow from the animal or reflection from the lights? Did the camera alter the scene? What other animals were nearby but outside the frame? Science begins in observation, but it matures in doubt. Doubt is not weakness here. It is a form of respect. The deep sea punishes easy conclusions. A specimen collected once may not represent a species' normal form. A behavior filmed under bright lights may not be ordinary. A vent community observed in one region may differ from another. A trench animal may be adapted to local conditions in ways not obvious from appearance. The ocean's scale makes repetition difficult and necessary. Every confident statement has to be earned against pressure, darkness, cost, weather, and the vast inconvenience of being there. This is why the deep remains full of mystery despite modern instruments. Mystery is not the absence of facts. It is the space around facts when the world is large. We know sunlight fades rapidly in the upper ocean. We know the mesopelagic holds immense biomass and daily migration. We know bioluminescence is widespread. We know vents support chemosynthetic ecosystems. We know trenches contain life under extreme pressure. These are not guesses, but within each fact is a landscape of unresolved detail. Which species are where? How many? How do they interact? How do changing temperatures and oxygen levels alter their ranges? How much carbon do migrating animals transport? How quickly do deep communities recover from disturbance? How many forms of light signaling have we never seen because our instruments are too bright, too loud, too clumsy, too late? The last light beneath the ocean is scientific in this sense. It illuminates one question and reveals 10 more. There is a scene that repeats in many forms across ocean research. A scientist sees something unexpected on a monitor and becomes very still. The unexpected may not look dramatic to anyone else. A patch of microbial mat in the wrong place, a fish at an unusual depth, a flash pattern that does not match known behavior, a larval form near a vent, a coral garden where the map predicted bare rock, a scattering layer moving differently under moonlight. Discovery is often quiet because the person seeing it understands the implications before the rest of the room does. Wonder is not always loud. Sometimes it is a long silence followed by someone saying, almost carefully, "Can we go back?" The vehicle turns. The camera returns to the place. The ocean, indifferent to human excitement, may or may not offer the sight again. This uncertainty gives deep-sea work its emotional texture. The ocean is not a museum exhibit. It does not reset. An animal may leave. A current may change. Sediment may obscure a track. A vent plume may shift. Weather above may force the ship to recover the vehicle early. Equipment may fail. Batteries run down. Time is expensive. The deep has no obligation to be available when humans arrive. So when the light catches something, the moment feels almost borrowed. A comb jelly rotating in the beam, rows of cilia scattering color like moving neon. A Dumbo octopus folding its arms as it lifts from the bottom. A field of brittle stars raised into current. A black coral branch hosting small animals along its delicate skeleton. A snail moving near a vent flow hot enough to shimmer. A shrimp's eyes reflecting back as points of intensity. A blue flash beyond the reach of the lamps, gone before anyone can identify it. Each sight is a fragment. Together, the fragments build a sense not of completion, but of presence. The deep becomes less abstract, not less mysterious, less absent. That distinction may be the emotional core of ocean exploration. We do not remove the mystery by seeing. We remove the emptiness we projected onto it. The unknown remains, but it becomes inhabited. There is an old pattern in human thought. First, we imagine a place as empty. Then we enter it. Then we discover the lives and histories already there. Then we must decide whether that knowledge changes our behavior. Forests called wilderness were often homelands. Deserts called barren were full of adapted life. The deep sea called empty turns out to be populated by communities and processes we are only beginning to understand. The moral question follows the scientific one. What does knowledge ask of us? Not worship, not paralysis, not the fantasy that humans can have no relationship with the sea. We already have one. We eat from it, travel over it, warm it, acidify it, map it, cross it with cables, fill parts of it with noise, and depend on it in ways most of us rarely notice. The question is whether our relationship can become less careless as our vision improves. A light lowered into darkness is not enough. The hand holding the light matters. Some nights on a research ship, after a long dive, people gather around footage again, even though they are exhausted. They replay a moment, freeze a frame, compare notes. An animal that appeared briefly becomes the center of conversation. Someone searches a database. Someone sketches a body plan. Someone emails a colleague. The ship continues through black water. The world above the horizon sleeps or storms or turns toward morning. Below, the animals go on without knowing they have entered human attention. There is something moving about that asymmetry. We may be changed by seeing them. They are not necessarily changed by being seen, unless our seeing leads to actions that reach them later. The best ocean science carries that awareness like a quiet weight. It knows that every discovery expands responsibility. It knows that naming a species does not own it. It knows that footage is not the whole world. It knows that light can reveal and disturb. Near dawn, the deck begins to gray. The surface returns. The same ocean that held blackness all night now reflects pale sky. The vehicle comes back up dripping and scarred, with small evidence of pressure and work. Samples are carried inside. Drives are backed up. People who have watched the deep for hours step into morning air, blinking. The sun rises over the sea. For a moment, everything is light again. But the people on the ship know better now. Under that brightness, under the shining surface, the night continues. It is not waiting for evening. It is already there, layered beneath them, filled with drifting bodies, patient hunters, chemical fires, and small blue signals traveling through water no sunrise can enter. The animals of the deep often seem to arrive from the edge of a dream because they are not arranged around human familiarity. A face is not always where we expect it. A mouth may dominate the body. Eyes may be enormous or nearly absent. A stomach may be visible. Fins may look like wings, oars, ribbons, threads. Some creatures are so transparent that their organs appear suspended inside them like small colored secrets. Others are so dark that they absorb nearly all the light that touches them, turning the body into a moving absence. Some are armored, many are soft. Some look ancient because their designs have changed slowly. Others look impossibly experimental. But evolution is not experimenting in the artistic sense. It is editing under pressure. The deep sea edits ruthlessly. In a low-food environment, unnecessary tissue becomes costly. Heavy skeletons are not always useful in water that supports the body. Bright pigments that would stand out in blue light may disappear. Muscles may be reduced if bursts of speed are less important than patience. Mouths may enlarge because any meal might matter. Eyes may grow to catch faint signals or shrink where vision is less useful. Reproductive strategies may become extreme when mates are rare. Light organs may become as important as teeth. Take the anglerfish, often reduced in popular imagination to a floating mouth and a glowing bait. The caricature misses the deeper strangeness. In the black midwater, where bodies are scattered across enormous volumes, the problem of finding food and finding a mate are both severe. The lure solves one problem by making hunger visible to prey. The sexual biology of some deep-sea anglerfish solves another problem through a form of attachment that feels alien to us. The tiny male finds the female and fuses with her, becoming dependent, providing sperm when needed. In a world where finding each other once may be nearly miraculous, never letting go becomes a strategy. This is not romance as humans imagine it. It is biology shaped by distance. The gulper eel offers another lesson. Its enormous mouth seems disproportionate, almost absurd, until scarcity is considered. If food is unpredictable, the ability to engulf a large prey item becomes valuable. The body behind the mouth is slender, energy-saving. What looks monstrous is partly an accounting system. Invest in the structures that make rare opportunities count. The same logic appears again and again. Deep-sea fish with expandable stomachs, predators with long teeth angled inward so prey cannot easily escape. Animals that drift rather than chase. Lures that reduce the need to search. Slow metabolisms, delicate bodies. In the deep, survival is often less about domination than about not spending what cannot be replaced. Then there are animals that avoid being seen not through darkness, but through near invisibility. Transparency is common in the open water because there is no background to hide against. On the sea floor, an animal can match sediment or shelter in structure. In the midwater, there is only light from above and darkness around. Pigment can create silhouette. Transparency lets the water show through. But transparency has limits. Eyes, stomach contents, and certain organs cannot easily disappear. Some animals minimize them, some reflect. Some position organs in ways that reduce visibility from below. The result can be beautiful in a way that almost erases the violence of the problem. A transparent shrimp hanging in the dark. A larvation inside a mucus house filtering particles. A glass squid with eyes that may point upward, its body nearly invisible except for organs and like points. A salp chain moving through the water like a loose necklace of living barrels. These animals are not trying to be delicate. They are trying not to die. In the deep ocean, color itself becomes strategic. Red animals can appear black because red wavelengths vanish in the upper water. A shrimp or fish that looks vividly red under a ship's lamp may be effectively dark in its natural habitat. Black skin can absorb bioluminescent flashes, reducing reflection. Some fish have ultra-black surfaces that make them extraordinarily difficult to detect, even when a little light touches them. This is camouflage not by blending with a background, but by refusing to return light. To be seen in such a world may be fatal. Yet to find food and mates, animals must sometimes reveal themselves. This tension creates some of the most fascinating light organs in the sea. A hatchetfish can shine downward to match the overhead brightness, but if it misjudges, it may become more visible. A lanternfish's pattern may identify its species, but it may also attract attention. A dragonfish's private red illumination gives it an advantage, but only within the limits of its own eyes and prey. No adaptation is free. The deep sea is not a place of perfect solutions. It is a place of trade-offs made under darkness. Some animals use scale differently. Siphonophores can be long, delicate, and colonial. A single organism in the functional sense may be composed of many specialized units, some for feeding, some for reproduction, some for movement. The whole can stretch through the water as a nearly invisible fishing apparatus. A prey animal blunders into tentacles armed with stinging cells, and the apparent emptiness becomes a trap. In the lights of a submersible, a siphonophore may look like a drifting line, a fragile ornament, an accidental shape. It is none of those things. It is a system. The deep rewards systems. A colony can divide labor. A symbiosis can create light. A microbial mat can support animals. A whale carcass can become a succession of communities. A vent can become a chemical city. Even the daily migration is a system, billions upon billions of individual decisions adding up to a planetary movement. We tend to look for charismatic individuals because that is how stories work. The ocean keeps offering networks. Still, individual encounters matter. A Dumbo octopus filmed above the seafloor can change how a person feels about depth. Its fins move gently. Its arms are webbed. It does not resemble the violent fantasies once projected into the deep. It appears almost tender, though tenderness is our word, not its purpose. A serrate octopus moving through cold darkness is a predator, a survivor, an animal adapted to pressure and scarcity. But its softness unsettles our expectations. It asks us to recognize that the deep is not only teeth and lures, it is also grace. The vampire squid does something similar. Its name is theatrical, but the animal is subtle. It lives in oxygen-poor mid-water zones, feeds largely on marine snow and detritus, and can use light organs and defensive postures. When threatened, it may invert its webbed arms over its body, exposing spiny-looking structures called cirri. It can release bioluminescent mucus. It looks like a creature designed by folklore, but its life is built around efficiency in a difficult habitat. Again and again, names reveal more about human imagination than animal reality. Vampire, devil, monster, alien. We reach for drama because the forms disturb our categories. But the animals are not trying to be symbolic. They are eating, avoiding being eaten, reproducing, sensing, drifting, migrating, glowing, waiting. Their lives are not metaphors until we turn them into metaphors, and even then, the animal remains beyond the metaphor, continuing in water. This is why a good deep-sea story has to remain grounded. The facts are already strange enough. A fish that makes red light in a blue world. A worm with no mouth living from bacteria inside its body. A daily migration so large it fools sonar. A trench animal living under 1,000 atmospheres of pressure. A jellyfish using light as an alarm. A squid making a glowing decoy. These do not need exaggeration. They need patience. Patience allows the fear to soften into recognition. The deep sea is not a haunted house. It is a habitat. Its creatures are not decorations for our dread. They are neighbors on the same planet, separated from us by depth rather than by imagination. Some may never encounter sunlight. Some may never touch the bottom. Some may live and die in the water column, held between a surface they do not reach and a sea floor they never see. Their world is not incomplete because it lacks ours. That is perhaps the most humbling thought. A bristlemouth does not need continents. A ventworm does not need sunrise. A trench amphipod does not need the moon. Life is not organized around the conditions we find beautiful. It is organized around whatever conditions can be survived, exploited, endured, transformed. The last light beneath the ocean is proof of that flexibility. It appears in organs, bacteria, mucus, warning flashes, hunting lures, mating signals, camouflage. It is life taking the absence of sun and making a tool from it. It is not rebellion against darkness. It is belonging to darkness so completely that even light becomes part of the dark. If the deep ocean could be misunderstood in one phrase, it might be this: far away. It feels far away because it is hard to enter. It is far from sunlight, far from air, far from daily human experience. But physically, chemically, biologically, it is not separate from us. Every breath we take belongs partly to ocean processes. Every climate pattern is shaped by the sea's storage and movement of heat. Every coast depends on the ocean's moods. The deep is part of that same system, slower and darker, but connected. The great vertical movements of animals in the twilight zone are one of the clearest examples. During the day, many remain deep, reducing the risk of being seen by predators. At night, they rise to feed in the upper layers. When they descend again, they carry carbon with them. Some of it is respired at depth, some is released as waste, some becomes food for deeper animals. This biological pump helps move carbon away from the surface, influencing how the ocean stores carbon over time. It is easy to make this sound mechanical, as if the animals are parts in a planetary machine. They are not aware of the carbon cycle. They are hungry. They are avoiding death. They are following light, darkness, scent, pressure, instinct, and opportunity. Yet, from these individual lives emerges a global process. The planet is often held together by creatures not trying to hold it together. A lanternfish fleeing daylight may be part of climate regulation. A zooplankton migrating upward under cover of night may be part of a carbon pathway. A fecal pellet sinking through dark water may matter in equations written by scientists far above. The ocean turns appetite into geochemistry. This is why the Twilight Zone has become a focus of growing scientific interest, It may contain enormous biomass. It may play a major role in food webs and carbon transport. It is also vulnerable to future exploitation. Some have looked at the abundance of mesopelagic fish and imagined fisheries. Others warn that removing organisms from this layer could alter ecological processes we do not yet fully understand. The question is not only how much life is there, but what that life is doing in the ocean's metabolism. The deep scattering layer is not just a target, it is a function. When sonar first revealed the false bottom, it offered a hint that the ocean's midwater was more crowded and dynamic than surface impressions suggested. Today, acoustics, nets, optical instruments, environmental DNA, and autonomous vehicles are all helping refine the picture. But the twilight zone remains challenging because its animals are mobile, fragile, patchy, and responsive to light. Measuring them is not like counting trees in a forest. It is more like estimating a city that moves vertically every night, turns off its lights when threatened, and dissolves if captured carelessly. This uncertainty should slow the appetite to harvest. The ocean has seen what happens when human extraction outruns knowledge. Whale populations reduced before their ecological roles were understood. Cod fisheries collapsed after seeming inexhaustible. Deep-sea corals damaged by bottom trawling before many people knew they existed. The pattern is old. Abundance appears infinite until it isn't. The deep sea, because it is harder to see, is especially vulnerable to being mistaken for empty or endlessly resilient. But deep systems often recover slowly. Low temperatures, slow growth, delayed reproduction, and scarce food can mean that damage persists. A trawl scar on the seafloor can remain visible. A coral broken in minutes may have taken centuries to grow. Sediment plumes can travel. Noise can spread. The darkness hides both harm and healing, making patience not only ethical, but practical. To care for the deep, we need more than awe. Awe can be fleeting. We need memory. Memory of how often the sea has surprised us. Memory of how quickly exploitation can become normal once it becomes profitable. Memory that the absence of public visibility does not mean the absence of consequence. Memory that a place can be scientifically unknown and still morally real. At the same time, the deep ocean cannot be reduced to vulnerability. It is also powerful, dynamic, and vast. It absorbs heat, stores carbon, circulates water, feeds animals, shapes weather, and holds histories in sediment. It is not a fragile ornament. It is a major part of Earth's functioning. The point is not that the deep is delicate in every sense. The point is that its particular strengths and vulnerabilities are not yet fully understood, and ignorance paired with power is dangerous. The darkness asks for restraint. There is a philosophical temptation to treat the deep sea as a mirror for human feeling. We descend into darkness and find our fears. We see lights and find hope. We watch strange animals and find metaphors for loneliness, survival, beauty, adaptation. Some of that is inevitable. Humans make meaning. But if we only use the deep as a mirror, we fail to meet it. The ocean is not valuable because it resembles our inner life. It is valuable because it is itself. A vent worm does not need to teach perseverance. A lanternfish does not need to symbolize hidden potential. A jellyfish flash does not need to become a lesson about hope. They can simply be what they are, and that can be enough. Still, there are moments when the ocean's reality touches human feeling directly. A blue flash in the dark can move us because it is both alien and understandable. It is a signal. We know signals. A creature trying to be seen by the right eyes or unseen by the wrong ones is not human, but the tension is recognizable. To live is to negotiate exposure. To be alive is to need and fear contact. The deep sea expresses this, not in words, but in light. The last light beneath the ocean carries that double nature, utterly biological, and yet emotionally resonant. A mating signal may look like loneliness to us. A defensive flash may look like panic. A lure may look like deception. Counter-illumination may look like self-erasure. We should be careful with these translations, but we need not deny that they affect us. Wonder begins in perception. Understanding begins when we ask what the perception means for the animal, not only for ourselves. Perhaps that is the discipline the deep sea teaches. Look, then look again. Feel awe, then become specific. Let beauty open the door, but do not let beauty replace knowledge. The deep has often been described as the final frontier on Earth. The phrase is useful, but it also carries a conquest flavor that sits uneasily with the subject. Frontiers are places empires imagine as empty. The deep is not empty. It is not waiting to be claimed. It is not final, because every answer changes the next question. It may be better to call it a continuing interior, a vast part of the planet that has always been there, not beyond us, but beneath the habits of our attention. Our age is unusual because the deep is becoming visible to more people than ever before. Live-streamed dives allow anyone with an internet connection to watch an ROV move over the seafloor. High-definition cameras bring the midnight zone into classrooms and living rooms. Scientists narrate discoveries in real time. A child can see a Dumbo octopus or a hydrothermal vent on a screen moments after a vehicle records it. The deep ocean is no longer only the domain of ships and institutions. It enters public imagination through pixels. This democratization of wonder matters. People protect what they can imagine, but it also risks turning the deep into content, another stream of strange images consumed and forgotten. The challenge is to let visibility become relationship rather than novelty. A clip of a glowing jellyfish is beautiful. A life in context is more demanding. It asks where the animal lives, how it feeds, what threatens it, what it reveals about the ocean, and what obligations follow from knowing it exists. The last light beneath the ocean, seen through a screen, can become a beginning if it changes the way we picture the planet. Not as land with blue margins, not as surface with depth beneath, but as a mostly dark, mostly oceanic world where the sunlit places we inhabit are only the bright edges of a much larger living system. That realization is not meant to make us feel small in a sentimental way. It makes us accurate. Far from vents, far from trenches, far from the obvious drama of a glowing lure, there are quiet places in the deep where the last light arrives as structure. A seamount rises from the abyssal plain like a mountain that never reaches air. Currents meet its slopes and accelerate. Particles carried through the water are lifted, concentrated, redirected. Animals gather where food passes. Corals and sponges can grow on hard surfaces, forming habitats that complicate the old image of the deep sea floor as endless mud. A ridge, a cliff, a volcanic cone, a fracture zone. Small changes in topography can become large changes in life. Deep-sea corals do not need sunlight. Unlike tropical reef-building corals, many cold-water corals live in darkness, capturing food from currents rather than relying on photosynthetic partners. They grow slowly, sometimes into complex branching structures that shelter fish, crustaceans, brittle stars, worms, and countless smaller organisms. In the lights of a submersible, a coral garden can appear suddenly from black water, white or orange or pink under artificial beams, an architecture of animals built in silence. The word garden is imperfect, but it persists because it captures the shock of finding structure where one expected emptiness. A coral garden in the deep is not lush in the surface sense. It may grow over decades or centuries. Its branches may be brittle. Its inhabitants may be small and specialized. It may depend on currents that deliver enough food to sustain it. Damage can be devastating because time is part of the structure. Break the branches, and one does not merely remove shape. One removes years, perhaps centuries, of accumulated habitat. The deep sea is full of time made physical. A sponge standing on the seafloor is not only an animal, it is filtration, shelter, surface, history. A glass sponge reef can alter local conditions and host communities. A coral skeleton records growth. Sediment layers store chemical traces of past oceans. Manganese nodules grow so slowly that their size is a clock almost beyond intuition. Even the tracks left by animals crossing soft sediment can linger in low-energy environments, temporary writings in mud that may last longer than footprints on a beach. The beach is constantly erased. The abyss remembers differently. This different memory can make the deep feel solemn, but solemnity is only one part of it. There is also activity, competition, predation, reproduction, disturbance. Brittle stars climb coral branches to catch passing particles. Crabs walk with deliberate movements over rock. Fish hover near structure. Anemones extend tentacles into currents. Sponges filter. Microbes work invisibly everywhere. A dead animal falls and transforms the local mood. A current shifts. Sediment lifts. A predator arrives. The pace may be slower, but life is not suspended. It is tuned to a different metronome. For humans, slowness can be hard to respect because it does not demand attention loudly. A forest fire, a bleaching reef, an oil spill, these are visible crises. A trawl passing over a deep coral habitat may be unseen by most people. A sediment plume drifting through abyssal water may not appear in public imagination. A slow decline in oxygen may not produce a single dramatic image. Yet, slow harm can be harm. The absence of spectacle does not reduce consequence. The same is true of deep wonder. Not every marvel flashes. Some simply persist. A coral polyp feeding in darkness. A sponge filtering for decades. A microbial community altering chemistry grain by grain. A seamount redirecting currents for millions of years. A trench accumulating particles. A vent chimney growing mineral by mineral. The last light beneath the ocean is sometimes not light at all, but the visibility our lamps give to persistence. There are places where fish gather over seamounts in numbers that attracted commercial interest. Orange ruffy, for example, became a symbol of deep-sea fishing's risk, a long-lived, slow-growing species vulnerable to overharvest. The lesson is broader than one fish. Deep life histories often do not match the pace of industrial extraction. A species that matures late and lives long cannot always rebound quickly from intense fishing. A habitat that grows slowly cannot be treated like a crop. Human systems like replacement. The deep often works by accumulation. That mismatch is one of the central tensions of our relationship with it. We are fast, hungry, and increasingly capable. The deep is vast, slow, and only partly known. To say this is not to argue that no human use of the deep can ever be justified. The ocean has always sustained human life. But use without understanding becomes a form of blindness, even under bright lights. A trawler dragging gear over unknown habitat is not acting in darkness because the sun cannot reach the seafloor. It is acting in darkness because knowledge has not reached the decision. True illumination would include maps, biology, recovery rates, species interactions, cultural values, climate effects, uncertainty, and restraint. A lamp alone is not enough. On a seamount slope, the lights of a vehicle may reveal a coral branch covered in small, brittle stars. The scene is intricate, almost festive. Arms extended, bodies attached, each animal taking advantage of flow. A fish moves past. Sediment drifts. The camera zooms. For a moment, the viewer sees a community that may have existed long before the dive, perhaps long before the ship above was built, perhaps before the grandparents of anyone on board were born. Then the vehicle moves on. The coral remains, if it is lucky. Luck should not be a conservation strategy. There is a strange intimacy in seeing such places. They are not accessible, not in the bodily sense. We cannot walk there. We cannot breathe there. We cannot hear them as they are. We visit through machines. Yet the footage can feel close, even private, because the darkness narrows attention. A single coral branch in a beam becomes the whole world for a moment. A small fish sheltering among it becomes not a statistic, but a presence. This is the gift and danger of cinematic seeing. It can make the distant intimate. It can also make the intimate consumable. The camera must choose. The narrator must choose. The viewer must choose whether to treat the deep as scenery or as a living reality. A slow documentary has one advantage here: time. It can allow the ocean to breathe. It can remain with a scene long enough for the first shock to fade and the details to appear. The way particles move in the current. The way an animal holds its position. The way a flash occurs at the edge of view and is gone before the mind names it. The way darkness is not background, but participant. The deep does not reveal itself well to impatience. Neither do old forests, glaciers, deserts, or night skies. Some realities require duration before they become visible. In the deep ocean, duration is not only a viewing technique, it is the condition of the world. The last light beneath the ocean may last less than a second, but the world that produced it is ancient. A biochemical pathway refined through evolution. A species shaped by countless generations. A water mass traveling for centuries. A seafloor formed by tectonics. A food particle descending through layers of life. A human vehicle lowered after decades of engineering and curiosity. When that blue flash appears, it carries all of that. Not visibly, but truly. A lighthouse is built for the surface. It stands on rock or shore, facing weather, sending a rhythm across waves so that ships can locate danger and home. Its light is repetitive, deliberate, public. It assumes an eye at a distance and a vessel that needs warning. The deep sea has no lighthouses in that sense. No towers, no coast, no harbor entrance, no fixed beam sweeping the water column for safe passage. And yet the deep is full of signals that serve a related purpose. Not to guide ships, but to negotiate distance in darkness. A lanternfish is a moving lighthouse only if we forget that it may be trying not to be seen. An anglerfish lure is a lighthouse only if the harbor is a mouth. A jellyfish alarm is a lighthouse only if danger can be redirected. The comparison breaks almost immediately, and that is useful. Human lights often promise safety, ownership, direction. Deep sea lights are more ambiguous. They can be invitations that kill, warnings that save, disguises that hide, announcements that risk everything. They are not symbols placed into darkness. They are acts. This ambiguity may be why bioluminescence feels so hypnotic. A glow in the deep does not tell us what it means. It asks us to wonder who it is for. The animal producing it may not be visible. The receiver may be outside the frame. The signal may be incomplete without a behavioral context we missed. We see the flash, but not necessarily the conversation. Much of the deep sea is like that. Evidence without full conversation. A track in sediment. A bite mark on a whalebone. A chemical plume. A sound in a hydrophone. A light pulse in the water. A species known from one specimen. A larva whose adult form was once unknown. A migration seen as sonar color. A community inferred from environmental DNA. Science is built from such traces, but traces require interpretation. The deep ocean keeps reminding us that knowledge is not the same as possession. We can record a flash and still not know what it meant to the animal. We can map a vent and still not know how larvae find it. We can measure carbon flux and still not know every biological pathway that shaped it. We can name a species and still not understand its life. This should not discourage us. It should make our curiosity more careful. There is a difference between mystery as a fog that prevents knowledge and mystery as a depth that invites better questions. The deep sea offers the second kind. It is not unknowable in a mystical sense. We are learning it, slowly, instrument by instrument, dive by dive, genome by genome, observation by observation. But it is too large, too varied, too dynamic to be reduced quickly. The mystery persists because the world is abundant, not because science fails. The surface has its mysteries too, but they are often hidden by familiarity. Waves seem ordinary until one studies their physics. A tide seems simple until one follows the moon, coastlines, basin shapes, friction, and resonance. A fish market seems practical until one traces the life history of each animal, the currents it crossed, the food web that built it, the people who caught it. Familiarity is not understanding. It is only repeated exposure. The deep lacks even that. We have not been exposed to it enough to become casually blind. Perhaps that is a gift. The first time someone sees a deep-sea creature glowing in black water, they are unlikely to feel bored. The challenge is preserving that attention long enough to move from spectacle to relationship. To ask not only what is that, but where does it live? How does it feed? How does it reproduce? How many are there? What threatens it? What does it tell us about the ocean? What might we damage before we understand it? A light should lead to questions, not just applause. In some parts of the ocean, the last sunlight disappears gradually enough that there is no exact moment to mark. A camera descends, and the blue simply thins until the lamps become necessary. In other places, turbidity or plankton clouds shorten the light's reach. The descent can feel faster, the surface gone sooner. But wherever the transition occurs, it carries a subtle emotional force. Above, the sun organizes perception. Below, the ocean organizes itself around other rules. This is the threshold the title points toward. The last light beneath the ocean is not only a location, it is a change in authority. At the surface, light reveals the world. In the deep, light becomes part of the world's strategy. At the surface, darkness interrupts life. In the deep, darkness is the condition life has mastered. At the surface, a glow is often decoration, celebration, signal for human convenience. In the deep, a glow is a biological sentence written under pressure. If we follow that sentence far enough, It leads us through nearly every major theme of the ocean: physics, chemistry, evolution, geology, climate, exploration, humility. Light begins as astronomy, the sun radiating across space. It becomes optics as it enters water. It becomes ecology as organisms chase or avoid it. It becomes chemistry in bioluminescence. It becomes geology at vents, where life flourishes without it. It becomes ethics when our own lamps reach habitats we might alter. A single idea threads through the entire descent, and yet the ocean refuses to become only an idea. It remains physical. Cold water against metal, condensation inside a viewport, pressure on a hull, sediment lifting from a thruster, a crab stepping over basalt, a fish turning its eye toward a lamp, a blue flash vanishing beyond the camera. The physical details keep the story honest. Without them, the deep sea becomes abstraction. With them, it becomes place. Place does not require human footsteps. Most deep places will never be touched by a human hand. They are still places. A trench slope is a place. A vent chimney is a place. A mid-water layer at 600 meters under a moonlit sea is a place, even though it has no floor or wall. A current crossing a seamount is a place for the animals that use it. A whale fall is a place for as long as it feeds a community. The ocean expands our definition of place beyond land's conveniences. A place can drift. A place can be vertical. A place can be temporary. A place can be made of chemistry. A place can be a layer of animals rising at dusk. The last light beneath the ocean belongs to such places, and because they are difficult to visit, they ask for imagination disciplined by fact. Not fantasy, but informed imagination. The ability to picture a world we cannot inhabit directly while resisting the urge to make it ours. That may be the deepest form of respect available to us. To imagine without possession. To illuminate without claiming. To study without reducing. To feel wonder without turning away from responsibility. There is a moment during some descents when the submersible pilot asks everyone to stop talking. Not for drama, for listening. Inside the sphere or cabin, the sounds are small. Fans, breathing, the faint movement of controls, the occasional creak as the vehicle adjusts to pressure. Outside, sound does not arrive the way it does in air. The vehicle is sealed from the water, insulated from the full acoustic life around it. Still, the request changes the atmosphere. The people inside become aware of their own presence, their heartbeat, the thinness of the human bubble, the impossible quantity of ocean pressing around it. Silence in the deep is never absolute, but human silence can make space for humility. The lights show what they show: a slope of sediment, a scattering of rocks, a pale anemone, a crab, a small fish hovering just outside the brightest part of the beam. The fish does not flee immediately. It holds position, adjusting fins, perhaps assessing the vehicle, perhaps stunned, perhaps indifferent. Its eye reflects a point of light. For a few seconds, two worlds meet, one built of air, language, instruments, and return plans, the other built of cold water, pressure, darkness, and needs older than human speech. Then the fish turns away. The encounter ends without conclusion. Many of the best deep-sea moments end that way. They do not resolve. They do not deliver a moral. They do not become a neat revelation. They simply widen the world. A creature appears, and the viewer must live with the knowledge that such creatures are there, mostly unseen, continuing after the camera leaves. This is why forced conclusions feel wrong in the deep. The ocean does not conclude. It circulates. It transforms. It receives. It erodes. It shelters. It surprises. A human story may need an ending, but the sea resists finality. Even death becomes process. A carcass falls. Microbes bloom. Scavengers arrive. Bones feed communities. Sediment covers remains. Chemistry changes. Matter moves on. Nothing in the ocean is simply over. It is moved into another form. Light, too, changes form. Sunlight becomes plankton. Plankton becomes animal. Animal becomes snow. Snow becomes food. Food becomes motion. Motion becomes migration. Chemical energy becomes bodies at vents. Bioluminescence becomes signal. Signal becomes survival or death. A lamp becomes data. Data becomes care or policy or memory, or sometimes nothing at all if we fail to act on it. The journey of light beneath the ocean is not a straight descent. It is a series of transformations. Perhaps that is why the deepest darkness does not feel empty once we understand it. It is full of transformed light. Not brightness, but consequence. A fish in the midnight zone may carry in its tissues carbon fixed by sunlight weeks or months before. A vent worm may depend on chemical energy from Earth's interior and oxygen from a surface shaped by ancient photosynthesis. A deep coral may feed on particles descending from above, its branches growing in a night that still depends on distant productivity. A trench amphipod may eat what gravity delivers. Even in darkness, the world is connected by histories of energy. The phrase "last light" can sound final, but in the ocean, finality keeps dissolving. The last visible light is not the last influence of the sun. The last sunlit particle is not the last food. The last flash of an animal is not the last signal. The last lamp of a submersible is not the last presence of the place. After the vehicle leaves, the deep does not become less real. It becomes unobserved again. That is all. Unobserved reality is perhaps the hardest reality for modern humans to respect. We live in an age of images, documentation, proof, sharing. A thing becomes more real to us when it is recorded. But most of the ocean is not being recorded. Most lives in the sea will never appear on a screen, never be named, never be counted individually, never become symbols. They will still happen. Eggs will drift, larvae will rise and settle, predators will wait, microbes will divide, signals will flash and fail and succeed, bodies will fall, currents will carry. The deep is not waiting for witness. Witness is our need. The ocean has its own continuities. This does not make witnessing unimportant. On the contrary, because we are now capable of changing the deep, witnessing becomes necessary. We need to see enough to know what is at stake. But we should hold the act of seeing lightly, knowing it is partial. The view through the viewport is not ownership. The camera feed is not the whole ocean. The sample is not the entire species. The map is not the habitat. The model is not the life. Every good map has edges. Every beam has darkness beyond it. There is comfort in admitting this. It frees us from the false burden of total understanding and gives us the truer task of careful attention. We do not need to know everything to begin caring. We need to know enough to recognize that ignorance is not emptiness, and that the unknown may be living. Somewhere in the twilight zone tonight, as the surface darkens, animals are beginning to rise. They do not rise all at once. They rise according to size, hunger, risk, moonlight, temperature, current, and the ancient arithmetic of survival. From above, the ocean surface may look calm. Beneath it, a vertical migration is unfolding, a slow upward storm of bodies. Some will feed and return. Some will be eaten. Some will release eggs. Some will carry carbon downward before morning. Their lights, if seen, will be brief. Somewhere deeper, in the midnight zone, a lure sways. Somewhere, a squid releases a cloud of light and escapes. Somewhere, a jellyfish, touched by a passing predator, sends a ring of blue through its body. Somewhere, a black fish absorbs the flash and remains nearly invisible. Somewhere, a dragonfish opens its mouth in a darkness it can partly illuminate for itself. Somewhere over the abyssal plain, marine snow is falling. Somewhere on a seamount, brittle stars hold their arms into current. Somewhere near a vent, microbes are turning chemistry into food. Somewhere under the seafloor, in warm cavities near rising fluids, animals occupy spaces we did not know to imagine. Somewhere in a trench, pressure holds the world in a form we can barely enter, and life continues there without sunrise. The scale of these simultaneous happenings is almost impossible to carry. The ocean does not offer a single mystery. It offers countless ordinary mysteries at once. And each ordinary mystery belongs to a place, a body, a process, a relationship. The last light beneath the ocean is not one light. It is a scattered grammar of brightness across a planet of water. The more we learn, the less the darkness looks empty. The more we learn, the more careful the word darkness becomes. It no longer means nothing. It means hidden photosynthesis carried downward. It means chemistry without sun. It means bodies tuned to pressure. It means signals too brief for us. It means patience. It means distance. It means life organized around rules we are still learning to read. Late in the dive, the pilot dims the lights again. Not all the way at first. The main beams lower until the seafloor loses its hard edges. The rocks soften. The particles fade. A pale animal near the sediment becomes a suggestion and then disappears. Not because it has moved, but because the borrowed daylight around it has been withdrawn. The control screens still glow inside the cabin. Numbers still hold the vehicle in human understanding. Depth, time, heading. But outside, the ocean resumes itself. Then the last lamp goes dark. For a moment, there is nothing to look at. The eye, hungry for form, reaches outward and fails. The mind tries to build a wall, a distance, an object, but the black water offers no help. It is a rare experience for modern people, true darkness in a living place. Not darkness above a city with a faint horizon, not darkness in a bedroom full of known furniture, not darkness on a rural road under stars. This is darkness with no sky, no ground visible, no familiar geometry. It is the absence of visual permission. And then, slowly, the ocean answers. A single point of blue appears to the left, far enough away that it might be small and close, or larger and distant. It glows, fades, and is gone. Another flickers below. A faint greenish spark trembles ahead. Something flashes twice in a pattern too quick to interpret. Tiny lights appear and vanish like thoughts crossing an unseen mind. None of them reveal the whole scene. None of them make the darkness less dark. But each one proves that the darkness is occupied. The feeling is not comfort exactly. It is more complicated. The lights are beautiful, but they are not for human reassurance. They belong to risks unfolding in water. A predator may have moved, a body may have been touched, a mate may have signaled, a lure may have opened its small theater of deception. A drifting animal may have spoken in the only language that travels far enough here. The people inside the machine witness only fragments of a conversation in which they have no part. This is the closest the deep sea comes to stars, not because the lights are distant suns, but because they change the meaning of darkness. A night sky full of stars reminds us that darkness can contain fire beyond measure. A deep sea scattered with living flashes reminds us that darkness can contain life beyond expectation. But the comparison ends there. Stars burn by mass and gravity. Deep sea lights burn without heat, briefly, biologically, in bodies that must eat, hide, mate, and survive. Their scale is smaller. Their urgency is closer. The submersible drifts. No one speaks for a while. The darkness outside is no longer empty to anyone in the cabin. It has become layered with possible animals, possible signals, possible distances. The mind has changed. Earlier, black water meant the limit of seeing. Now it means a world continuing beyond sight. This is one of the quiet transformations the ocean performs on those who descend into it. It does not give them mastery. It changes what they mean by unknown. Above, the ship waits on the surface, lights glowing in the night air. Above the ship, clouds move. Above the clouds, the moon may be rising, or hidden, or absent. The sun is on the far side of Earth, pouring light onto another ocean, another coast, another field of waves. The planet turns. Dawn is always happening somewhere. But here, where the vehicle hangs in black water, dawn has no authority. Still, light exists, not as a season, not as weather, as a living act. A small animal makes it and spends it. The idea is almost tender. Light as something a body can choose to release. But choice may be too human a word. The reaction is controlled by nerves, hormones, touch, hunger, fear, inherited patterns, circumstances. Yet from the outside, it feels like decision because it is so precise. A flash, then darkness. A glow, then nothing. A soft pulse traveling along a bell. A luminous cloud opening in water. A tiny lamp under a jaw. The ocean writes with vanishing ink. Every flash leaves no trace in the water, but it can leave a trace in the animal that sees it. A predator turns. A mate approaches. A prey animal escapes. A larger hunter is summoned. A silhouette disappears. The light is gone, but the consequence remains. That may be the deepest way to think about the last light beneath the ocean. Not as something that survives by lasting, but as something that survives by changing what happens next. A photon travels, enters an eye, triggers a response. The sea returns to black, but the path of a life has shifted. Most human lights are built to persist. Street lights through the night, screens through the evening, cities visible from orbit. We make light into occupation. The deep often makes light into event. It appears, does its work, and disappears. It does not dominate darkness. It uses darkness. It respects the power of absence because absence is what makes a signal possible. If everything were bright, the signal would vanish. If everything were visible, the lure would fail. If darkness were truly empty, the flash would mean nothing. The deep sea is therefore not a battle between light and dark. It is their collaboration. Darkness gives light value. Light gives darkness detail. Life moves between them, shaping both into tools. The vehicle's lamps come back on. The sea floor returns in pale color. Rocks, sediment, a small animal track, a brittle star partly hidden under an overhang. The sudden brightness feels almost crude after the delicate flashes. Necessary, but crude. The machine begins to rise. Thrusters stir the water. The bottom drops away. The vehicle enters the water column again, leaving the sea floor to its slow processes. As it ascends, the instruments unwind the descent in reverse. Hadal pressure, if the dive has been deep enough, gives way to abyssal pressure. Abyss to midnight. Midnight toward twilight. The temperature may shift, the density changes. The kinds of animals appearing in the beam change. At some depth, the bioluminescent flashes become more frequent again, disturbed by the vehicle's motion through the mid-water. The ocean seems to sparkle around the intrusion, not continuously, but in little bursts of response. Then, higher, a faint blue begins to gather. At first, it is so weak that it might be imagined. Then, the water ahead becomes less absolute. The surface is still far above, but the sun has returned as a rumor. The first natural light after hours of darkness can feel almost unbelievable. Not beautiful in the easy way, more like a memory recovered. The water turns from black to blue-black, then to blue. Particles become visible without lamps. Shapes gain distance. The ocean ceiling brightens. The human body, even sealed inside a machine, recognizes something ancient: the direction of day. The ascent passes through the last darkness in reverse, and the sun resumes its old authority. But the descent has altered it. The surface light no longer feels complete. It is only the upper expression of a larger planet. The waves above are real, but so are the flashes below. The sunlit water is real, but so are the animals that never see it. The glitter of afternoon on the sea is real, but beneath it, in layer after layer, darkness continues with its own intelligence of forms. When the vehicle breaks the surface, water streams from its frame. Crew members secure lines. Voices grow louder. The ship moves under open sky. The horizon returns, clean and human, dividing the world into above and below. The dive is over, but below the hull, the ocean has not ended. It has simply become hidden again. Far beneath the ship, the twilight zone is preparing for dusk or retreating from dawn, depending on the hour. Deeper still, the midnight zone remains unchanged by the surface weather. On the abyssal floor, a sea cucumber crosses sediment slowly, leaving a track that may outlast the day above. Near a vent, hot fluid rises through mineral chimneys into cold water, feeding microbes that feed a community. In a trench, pressure holds darkness against the seafloor with a weight almost beyond metaphor. In the midwater, a creature with a transparent body drifts through the path of falling snow. In another place, an unseen animal flashes once. No camera catches it. No instrument records it. The light appears, meets whatever eye or body it was meant to meet, and vanishes. That unseen flash matters no less. The ocean is full of such unrecorded events. Most beauty on Earth is never witnessed by humans. Most signals are not for us. Most lives leave no archive we can read. The deep sea, perhaps more than any other realm, makes this plain. It continues beyond our documentation, not resentfully, not secretly in the dramatic sense, but simply because the world is larger than witness. Night settles over the surface again. A low swell moves under the ship. The stars appear between clouds, scattered and cold. Below, where starlight cannot travel, other lights begin and end in black water. Blue points, green pulses, brief rings, hidden lures, soft alarms. Bodies making brightness from chemistry, spending it carefully, returning to the dark that holds them. The last light beneath the ocean is never the last for long. It fades. Another appears somewhere else. A different body, a different need, a different darkness. And below the moving surface, beneath the blue, beneath the twilight, beneath the long midnight of water, the ocean keeps its quiet constellations. Not fixed in the heavens, but drifting, hunting, hiding, calling, answering, and disappearing again into the vast, cold dark. Hours later, when the ship has moved on and the wake has flattened behind it, nothing on the surface shows where the descent happened. The water closes without a scar. The night wind passes over the same waves it would have touched anyway. Flying fish, if there are any, break the surface for an instant and vanish. Farther off, a swell lifts, travels, and lowers itself again. The sea keeps no visible doorway. Below, the root of the vehicle has already dissolved. The disturbed particles have settled or drifted away. The animals that fled have returned to whatever distances feel safe. The ones that were drawn toward the lamps have resumed the old uncertainties of hunger and caution. The water column is dark again, but not restored, because restoration implies interruption was central. The deep was never suspended while the machine was there. It folded the brief brightness into itself and continued. A small flash opens in the black, then another. Not near the ship now, not for any camera, not inside a cone of human light. Just a living signal passing between bodies in a volume too large to name fully. It may be missed. It may be answered. It may save the animal that makes it, or betray it, or mean something more specific than those simple choices. The ocean does not translate. Above, clouds cover the stars. For a while, there is no visible light anywhere on the water except the faint lamps of the ship receding toward the horizon. Underneath, in the cold interior of the sea, brightness continues in scattered, fragile acts. It does not gather into a dawn. It does not become a map. It does not explain the darkness away. It only appears, briefly enough to be precious, clearly enough to matter, and then returns everything to the vastness that held it.